All right, so that recording's going there. Here's the link out to those Linux courses that I was talking about, and I'll just pull that up so you guys can see what that looks like. So there's a couple different Linux courses that NDG would offer, and the main reason I bring this up is Linux Unhatched, which is a nice free one for students. So all you have to do is have your students come in here, they quote enroll, and they would get access to that. And I used to have attendees and such go through here and do that. It's easy enough for you to go through here and mark these boxes to do such. And so we could claim our free access there as well. And there's your course content. And so this one is a really good one. I use it, quite frankly, at the beginning of all my master's courses in the cybersecurity content and curriculum. It doesn't matter which course it is. The first week, I just have students go through this content. That way, they're back up to speed on Linux. If it's been a little while since they've done it, they just need that little bit of a refresher. It works really, really well to try to get it up and going. Those that are teaching in like an 8-week format or something, you could use it in the first couple of days. You could easily get through it. It's about, quote, 8 hours worth of work, but it realistically doesn't quite take 8 hours. That's kind of the nobody knows what they're doing with Linux type hours. And so as students get a little more exposed, they can go through that. As you can see over here, content's over here on the left. So again, you're going to get the full content with a nice little virtual machine over here on the right. To be able to kind of learn some of these Linux commands. And it's going to take you through a bunch of different topics like how to view files, how to go through the file system, how to pull out different sections of content that you would need within Linux. So it's a really good little course that you can use through. And then if you chose, yep, I got you marked down here, Itza. All right. And then if you choose to go a little bit further with the curriculum and content, there are some Linux Essentials course out there as well as Linux 1 and 2. And so those are ones that we use in our Linux course here. In the early days, I helped develop some of those courses before they got a little revamped. But they're good coursework that is useful. Now, these do have a cost as they go through here, and the cost varies. I think this course is $29.95 if you do it through the online platform. And of course, if you have an NDG NetLab Plus system, you can get it for free through the system itself there if you have your self-hosted one. But this Linux Unhatched is available for free. Linux Essentials, I believe you can still get that for free through the Cisco Networking Academy. So you can simply click enroll and it will take you out through there and you should be able to enroll into that course as well. I believe it will redirect you through there. Yeah, actually you just get straight access to it. So that one will give you about, just complete that enrollment here. Yeah, so that one, Linux Essentials, is about 2/3, if I remember right, of Linux 1, or about a little over half of the same content between the two. So again, really good, cheap, free Linux material that's available for students as well as yourself. To get back up to speed on the Linux side. And then if you're looking for some ethical hacking labs, because they will kind of marry into some of the stuff that we're going in here today, and I'll bring up a little chart here that kind of shows what maps to what and what you should have in there. So let me do that here real shortly. Let's see. Just a second. Let's see if I can get that pulled up. So these are the labs that would be kind of important out of this series. Lab 3, 4, 6, 7, 8, 9, 12, and 15. As well as out of series 2, you're going to have lab 23 covering your tracks. Those are all topics that we would talk about here during this side. And then also out of the CYSA lab set, you can also grab these 4 labs as a way to kind of train people up. These labs, again, are available on the online service. You guys are going to get free access to these off of the my Fort Hays system here, and I'll get you guys some login credentials so that if you want to try some of those other labs that are relevant, as we can see here, we can definitely bring those in, and you guys can test yourselves on some of those. So, and then, like I said, there's the CYSA labs. There's a subset of those, about 4 of them. I'll try to get those deployed out here on the Fort Hays system and give you access to those as well. I I just can't remember if we got CYSA converted over to Proxmox just yet. So I'll have to double check that. All right. That's really it for the PowerPoint slides today. This last one isn't quite relevant because I'll get you guys logins for not critical infrastructure, but for the ethical hacking labs if you guys choose to do a couple of those today. For the critical infrastructure, you guys should be able to use the same logins that you guys had yesterday and get access to that. If you need that URL up there at the top, I'm happy to repost that. It's not a problem. Anybody have any questions over what we're planning for today or anything they would like to add? Like I mentioned yesterday, the workshop is for you guys. So if there's something that I'm missing or something you would like to cover in more detail, by all means, put it in the chat or come off mute. All right, then. So we'll get started in a couple of our labs. The first one here is going to be Lab 9, and that one's going to get us into scanning these industrial control systems. How many of you use Nmap in your classroom content? Or at least familiar with the product, the application there? Okay, good. About half of you. Great. So Nmap is a pretty fantastic tool. It's pretty easy for most people to utilize. Obviously, it's baked into Kali, but you can get ZenMap, which is the equivalent on the Windows side of the house if you want to install it and get a nice visual app. See if I can't launch it here on my machine in the background while it's doing this. So this is ZenMap, and you can download and install that software. It's free, open source. You can use the command line version Nmap itself if you choose to do so. ZenMap gives you just a nice UI so that you can pull some of these materials through there. So I could set up a target. So for example, if I wanted to scan a network, I could do something like 192.168.1.0 on a /24. And then I could go ahead and do different profiles of scans, like maybe just a quick ping scan or a quick scan across everything. All of these mean different things with different options that they're scanning for. And we're going to dive into those a little bit here in just a minute. And then, of course, I could hit scan and go through. Now, obviously, I'm not on that subnet, so we're not going to find anything coming through. But I'll go ahead and cancel that. And we'll come in. So I'm going to pop out this content here. Again, we'll cover a little bit of early content. Did this work yesterday in this format while I kind of walk through the lab and kind of give a little more info than what is just written in the lab? Did everybody like that style from yesterday, or would you rather go off and do the labs on your own during this time?
Oh, I like watching you.
Okay.
And then we go. Yes, and I like watching you because I follow you.
Okay. Okay. Great. Great. I just, like I said, everybody has a different learning mechanism, so I want to make sure everybody was happy with the way it was working. So, all right. So we'll get this content up here. We'll let that load up. Let's see what we got here. Yeah, that's unfortunately that's the instructor in me, Tom. I'd like to fill dead air. All right. So it's going to have us start off with the SCADA system. Again, we're probably going to get everything fired up like we're used to all the way through here. So we'll get that HMI up. We'll get a couple other options up and going. So let's pull up the SCADA. Our super duper password. I probably should have developed a better password. We now use different passwords for that, but honestly, when we were doing this, it was kind of a beta test to get CISA to work with us and do a proof of concept, and then it escalated really fast and became a working lab set. So yeah, that sounds great. I'm glad it's the mechanism that you guys like to learn. That's perfectly fine by me. So on this side, let's go through and start FUXA. Remember, FUXA is the name of our SCADA system. And it's also our HMI in this case. So it's a 2-in-1. And then we'll go ahead and launch up the UI. Again, other SCADA systems that I mentioned yesterday would have been SCADA BR. That's another one that's kind of open source and it's kind of fairly commonly used in some environments. And then most of the time in most environments, you're going to see more of the vendor's version of whatever SCADA system. So if you're using Allen Bradley or something like that, they're going to have their own setup and configuration there. All right, so like most of these labs, you're going to need to launch the particular UI. In our case, we're going to launch back up our tank fill sim. And on the PLC, we need to start up OpenPLC and have it do the runtime. And you'll notice in this lab set, let's see, is FUXA an acronym or is that really what they named it? That's what they named it. So the GitHub that we pulled up yesterday kind of goes through there. I was trying to remember if there was an acronym. I don't believe it was. That's just really what he named it there. Was kind of a web-based process visualization. So. Can't say that I know the history behind why it was called what it was. It's a good thing though. Yeah, and here's the GitHub on it. There you go. All right, so we're going to get our OpenPLC login. And we'll need to update our program, upload it rather. And again, we're just using the basic tank fill sim. This went through successfully. It looks like it did. And then we can go ahead and start our little PLC. And it looks like everything's up and going. So back on our SCADA system, we can go ahead and make sure we tie it in. We can also check our monitoring tab here again, just to make sure everything's working like it should. And we can see our tank is currently filling up over the top here, or starting to fill up from being low. Over the top would be the fountain outside my window this morning. Evidently grounds forgot that the hose was turned on. So. All right, SCADA side. Let's click on the settings cog and our connections and our little edit button. And we need to point over to our PLC. Remember, our PLC is running on .10 with a 502 for Modbus. That might be one to kind of know too, that Modbus runs on port 502. And if everything goes well, you should get your green little dot over there. And we can double check all of our device tags, make sure we're familiar with what we're seeing there. We'll go to our editor and we can hit our play button to make sure that we're watching this live. We can see everything seems to be working pretty well. We'll click on the expand here. And we're currently in the downflow, right? So it's currently draining the tank out. So now we're going to play with our Kali system. Again, we'll launch up Kali here. And I know this seems like a lot of prep work in the beginning of every lab, but the beauty of the lab set, the way it's written, is we don't have to have multiple copies of the virtual machines. They're all set up so that we can do all 14 labs off the same VMs, which is a pretty common method that we got to utilizing at NDG. Plus, the students get more familiar with those two products every time they have to launch those particular apps. All right, so we're going to get into our command console and just make sure that we're on the right network. Again, we're wanting 2.5. We can confirm our topology that, again, we're running on the 2.0 network and the Kali Linux is running on .5. So from here, we're going to play with the command line tool of Nmap itself. And so to do a simple scan on the command line, it would just be nmap, and then we can scan our 2.0 network. Now, by default, we're only going to find a couple of IP addresses, right? And based off that topology, we should be able to see ourselves at .5, obviously. And then we should see a 2.10, which is that SCADA device, and we should see our .1, which is our firewall. So we'll let it go through. And sure enough, we have our .1 that's coming through here. We can see on .1 that we have a couple ports open, both DNS, port 80 and 443. On 2.5, which is our SCADA system, we currently just scanned the main 1,000 ports. We didn't really find anything. And on our 2.10, we happen to have FTP that see's to be up and going. So we can even see here on our .1, and we can kind of confirm that this is what we think it is. So if we come out here and do a 192.168.2.1, sure enough, we get a web page, and we accept that risk, and we can see that it's the little pfSense firewall that's running over here on .1. So Nmap's a pretty good tool. Like I said, it looks like most of you are at least familiar with how it works and the process that it goes about using it. What we have to be a little careful for in a SCADA environment or a PLC industrial control style environment, we have to be careful not to be too aggressive with the amount of pings and the amount of scans. Because again, this is old equipment and it was never designed for Ethernet. Ethernet was always an add-on to the environment. So in order to get that to work correctly, we have to be a little careful and a little cautious on how we use things. So on this side within Kali, we'll use our sudo nmap -a-p, which will give us a port range. And we will do everything from 20 to 2048. So a little bit bigger range than we did before. We'll use our O switch and our 192.168.2.10 with APN and Kali being our password. So what does that all end up doing? The idea there is that the O is going to help us identify the operating system as we go through, and PN is going to help us with our ports. And so it's going to try to identify what more information on those ports as it goes through there. And we specifically are looking for that 2.10, which is that SCADA device. So we're trying to figure out what ports are open on the SCADA device. It'll take a little second to complete here as it scans over that device. All right. And so when it comes up, we can see on port 21 that we have FTP up and going there. And that we can see on 1881 that we have a web server up and going, and it appears to be running Node.js under the hood. And at the title of that is our FUXA system. And so that little scan revealed some information for us, that we have the FUXA running on a non-standard HTTP port, which is 1881. We go back to our SCADA system. We can confirm that this system is running locally on 1881. We also get some information about the operating system. We can see which kernel it's running there and a little bit more deeper information, but not much more than just kernel version. So it's good. It's a good way for us to kind of pull out what's going out there. It gives us some background information. We can also see that this is running on a VMware backend because the MAC address of this VM happens to be a VMware MAC address. So these are all good information for the hacking side of things that we can collect about the SCADA systems. Now, obviously, we have to get our way onto that network. We're not haven't demonstrated that yet. For now, we're just on the network trying to poke around. This would be somebody like an IT person that's looking to do an audit on their OT environment. But again, they have to be very careful as to how they go about the scanning procedure. So in a real world environment, all these scans in this section are kind of considered an active approach, and they all have the potential or consequence of being detected or scanning an old piece of equipment, which will cause it to hang and stop working. We're going to use a couple of different scripts here that Nmap offers that allows us to pull information out about things that you would do on a industrial control system network. And so if we go look at the scripts that are available for Nmap, you'll see there's a bunch of different ones out here. And these are just scripts that you can write using the Nmap scripting language that help you get additional information about particular devices besides just the port information we're going for. And so a couple that we're going to be interested in is BACnet. So if we come up here and we see this one, we can see this BACnet Discover or BACnet Info. BACnet is another one of those that is part of the industrial control system. It's another protocol in there. We can also see our ENIP IP. This one here, both enumerate and info. This is going to help us do a scan on any ENIP systems. And if you remember from yesterday, we were able to create our own Ethernet IP PLC controller that was running that protocol so we could gather information from it. We obviously have our Modbus one as well. So let's go over here and look at our Modbus one. My mouse would find it. There we go, right on top. So Modbus, that way we can discover some information on the Modbus side. And we also talked about S7 yesterday. Does anybody remember what company is associated with the S7COM protocol?
Siemens?
Siemens, yep. So again, Siemens is a pretty big company when it comes to PLC controllers, pretty common. They actually do have some training that they offer on their side, mostly commercial side. And at one point, I was really trying to work hard with them or Alan Bradley to get them on the academic side as well. So what we want to do is a little bit of testing on these to kind of see how Nmap would give us back that information. And so if we come into our PLC system, and for the time being, let's see here, go on the password. We're going to temporarily stop this controller that's running now. And if we open up a terminal, we are going to go ahead and start that same Python script that we played with yesterday. And what this does is just make this act like a Ethernet IP based PLC controller as opposed to a Modbus controller. So cppo dot server dot init, and we're going to listen verbosely on all our ports. And we have our tank station like we did yesterday. Okay. So again, all that did was start up a PLC server. In this case, that runs on the communication protocol of Ethernet IP so that we can run some Nmap scans against it, and this would mimic what it would be like to have real hardware. So if we come back to our Kali side, and let me get back here. Sorry, I closed my browser out on the wrong one there. Okay, so we're going to use that init script info that we were talking about before. So sudo nmap, come on. And we're going to use the script. And it's the enip info one with the -s and a u and a -p to go specifically on the port that we're looking for. So 44818, and that's what Ethernet IP runs on. And then we're going to point to our PLC controller. And on the PLC side, we should see some requests for information because we're essentially running the same type of commands that you would get inside there for that script itself. And what it's trying to do is attempt to figure out what vendor or what system that really is. And in this case, because we have that mimicking an Allen Bradley or a Rockwell Automation, we can sell the vendor information, the product, the serial number, and all that kind of stuff that shows down in here. So again, this is just a simple Python script that's speaking the same language that you would have with Ethernet IP. All of that's coming off that little config file that we talked about, and that config file is there in the CPPO, and we'd have to go into that folder. I'm trying to remember where that was from yesterday. Documents. Yeah. So this was that little configuration file, and you can see in here that we are using specific vendor IDs and device types and codes, and that turns out to be the Rockwell Automation and Allen Bradley stuff when it actually comes out on the other side. So you could have students kind of play. You could have them do a Google search, for example. This would be good for like our capture the flag type of environment. Is they need to go figure out the vendor ID and the device type to mimic a specific one that you ask them to do. And then they would have to configure this and see if they could get the Nmap script to put this out appropriately, like you would expect the results to be. So that would be one where you could tell them to reconfigure this this config file with, say, vendor ID 12, device ID 10, you know, whatever it is for the one that you want them to come out with, and then they would have to run their Kali command against that VM to figure out what type and model that ends up being. All right. Let's see. Another tool that's out there besides Nmap is called RustScan. Has anybody used the RustScan utility in their cyber classes? Okay. So RustScan is basically like having a ping tool that is extremely fast in the way it goes through and scans. So it's multi-threaded. It will go out and try to ping everything all at once versus something like Nmap that's going to sit there and kind of go one at a time as it goes through there. This one's actually going to thread this system out. So it's like running, if you have it scan an entire, 254 network, it's going to fire up 254 threads, go scan them all at once and send it back. As you can imagine, this puts a pretty good load on the network. And it's pretty easy to get detected using one of those kind of tools in that fashion. But it's a great way to kind of do a quick scan of the network and see what's all out there. In this case, not only can it scan or ping networks, it can also go through and scan all the ports. That part is threaded as well. So you can end up detecting 65,000 ports out there in less than 3 seconds. It's significantly faster than we saw on this Nmap scan. But like I said, it's obviously has its dangers running that in an industrial control network. So if we do a Rust scan here, on our SCADA BR system, what I misspelled there? Oh, forgot my tab. That was supposed to be a 0, not a dash. There we go. So in this case, the multi-threading is going across the port sizes, and so it's using 10 threads at a time in order to kind of go through and scan that entire host to see what the results would be. So as we did this little scan here, we got massive amounts of scans done in a relatively quick time. You can also see what it's trying to do here. So the scan it's running on the individual one is essentially an Nmap with extreme verbosity, with a port that it kind of goes through as a script, and then it fires off an async script to return all that information. So it's a pretty cool little tool. It's just like Nmap. It's essentially a scripted form of Nmap that allows you to thread things out and go a little faster. And we can see the results are pretty similar to what we saw before. We could also do a little bit more in terms of speed again. So if we try this with the dash and the dash A, this one's going to increase the batch size a little bit more and really try to scan hard and give us that extra level of detail on the services that are running. So this one just kind of gave you a top level version of what that protocol was and a rough service. If we wanted more information on there, we could pull that up as well. Yeah, in map, if you do a triple V, it gives more verbosity as it comes through there. And so we can see in this case, it's going to do more detailed scans. In this case, we found it wasn't just an FTP server, that it's actually running VSFPD on version 305. So now we could go find like vulnerabilities for that particular one, get some more details. We could again see that this is running Node.js, and that we have a bunch of different methods that we can currently run options against that, et cetera. So it gives us quite a bit more information. If you actually go back to your Nmap one that we did before, when we just scanned that host, that would be this one here. We could also come back in here and do our, and what you're going to see on that quote verbosity is just giving you all the information that's coming out of there. So it's going to do the ARP scan, then it's going to come through and run the different scripts based off the -O, which is going to try to figure out what operating systems and things like that. So it's just more detail that comes in here as to what you would see on this side. That's the kind of detail that you're seeing out here. Does that make sense, Terry? Cool. So it's a fairly short lab. The goal is to get people that are familiar with cybersecurity and the things you would get out of there. So for example, here, we tried to get it to fingerprint the operating system and figure out what version it was. In this case, because it's trying to use things like TCP sequence, et cetera, difficulty's too high, it's not really going to pull that kind of information out. But we can at least determine which Linux kernel it's currently running on. Obviously, this is an older version of Nmap there as well, because this is 2 or 3 years old and it doesn't pull updates. But we might be able to get newer versions of Linux and things like that to respond out of there. Great. So that's our first kind of bridge between IT and OT, where we take some of the tools that we're used to on the IT side and we use them inside of an industrial control network. In this system, I can tell you when I did this kind of scans against SCADA BR, which was that other SCADA system. So if you're looking to have students play with a couple different SCADA systems, this one is pretty common that's out there. It runs Apache Tomcat, and it actually would crash when we would do those kind of scans against it. It simply couldn't handle it. In some regards, sometimes it would work, but in other cases, it would just flat fail. All right. I'm going to end that reservation there. And we're going to start our first man-in-the-middle attack on an industrial control system. So now that we know what these IPs are on the network, things like that, now we're going to try to start gathering information. So from lab 10 to lab 14, what's kind of fun is, yes, we're going to give you the topology and kind of give you some background information. But as you're using this, say you use this in the classroom with your students, you would want them to kind of create a log. So start to figure out, okay, this system has this username and password. This is the IP address of this system. It's more like a capture the flag type of thing where you're coming in blind, you don't know what's what, and you have to work your way through the network to try to get to the ultimate PLC that's on the far end there. So those of you that like capture the flags or like challenge-based type labs, these next 4 labs are literally in line with that. Are we going to use EtterCap or are we going to see something new? A little bit of both. Yep. So there's a little bit of EtterCap. You're going to also see some new pivot tools that allow us to get in there as well. If you've ever used Empire and a couple other ones that are focused on Windows, that's kind of what we use to do some of the command and control type stuff. Like I said, it was actually a fun lab series to write because I hadn't got to use some of these other tools. Even though I, helped write some of the NDG ethical hacking labs and some of the other ones, never got a chance to really play with this specific tool set. It's actually kind of scary. If you if you go through this lab set, you can realize just how easy it is to compromise some of those Windows systems. And it's all because an admin did something, and it's a pretty realistic thing that an admin would do. And you're going to see that. As a matter of fact, again, this whole scenario is based off that attack on the Florida water distribution system. We basically recreated that scenario. And so the students are going through a lab series to learn about industrial control systems, but also how easy it is to break into these systems if an admin leaves something available for us to do that. So, all right, close that content out. Like I said, from here on out, the labs get a little longer. They're not quite as fast as we had seen in the other ones. Red Bull and jelly beans, I like it. All right, so if we do a little bit of reading here, we're going to end up doing a man-in-the-middle attack, and that will help us compromise the SCADA PLC side. And then we're going to end up doing a denial of service attack on that SCADA and PLC system. And we can see what kind of chaos that would cause inside of an industrial type environment. So we're going to end up setting up our SCADA environment like we've been doing. We're going to utilize a tool called Modbuster, which will start a man in the middle of the attack. Under the hood, it's going to do some other stuff. This particular tool, Modbuster, was written by a PhD student that worked with me on this lab set. They're actually doing this in mass industrial control systems. And so they wrote a cool little program called Modbuster in order to break up Modbus. And then we write to coils on the virtual PC, meaning we're going to then overwrite the data on that program logic controller. We're going to end up fooling the SCADA system by sending it random false data. And then we're also going to send it incorrect data, which would cause attacks. And then we'll end up doing a full-blown denial of service attack on it as well. Yeah, you got it. So we're gonna end up doing a man in the middle and then basically capturing those Modbus packets as they would normally flow between the PLC and the SCADA side, and then be able to tweak it, send it false data, incorrect data, randomize the data, which would cause the SCADA technician to kind of panic, right? So he might panic and hit the shutdown button, but because we overwrote the shutdown button underneath the hood, when he hits that button, he actually causes the system to start flowing and overflowing. We can do all sorts of stuff like that, which is pretty bad, pretty gnarly. So we're going to get our advanced tank sim simulation all back up and running. So let's go out to our SCADA system. And some of those tools, that's this whole thing builds. So lab 10 builds on lab 11, lab 12, 13, 14. Everything from here kind of builds on out. You can't just jump in the middle of those. So to start, we need to go ahead and start our FUXA. Okay, let's bring up our web interface and make sure that we have our UI up and going. Oops, if I could spell. Try to get a little French in there. All right, let's open our project. Tank fill. Great. And so our system appears to have pulled. This all looks good. Obviously, we need to point it out here in a little bit, but we got to wait till we get our PLC controller up and going there as well. So let's go out to our PLC system. All right. I know we tend to have to keep doing this over and over, but we end up having to load different ones each time here. So again, this time around, we're going to be running the advanced tank sim. So let's go ahead and upload that program. sure that all compiles and looks good. Back to our dashboard and go ahead and start our PLC. Okay, great. So we're up and running. We're going to look at our monitoring tab. And remember that just to make sure all the communications and everything's coming through. There you go. I saw you there, Cholo. We got you added in there. Anybody else that I'm missing from that original list? Let's see. Kenneth Gardner, not in here yet. And David. Okay, we're all caught up. All right, so again, what we're looking here is to check these systems, make sure our system's running properly. So we can see that the tank level is currently going up, and that's because we have the valve on and that we have our autofill command. And it hit 8 and it shut off, so everything's operating as we would expect it to. We'll want to pay attention to some of these addresses again, because again, we're going to try to overwrite these coming from the PLC in a couple different ways. We're either A, we're going to write things to the PLC itself, or we're just going to simply intercept the communication traffic and feed new data into it, even though we never touch the PLC itself. Both are going to be extremely harmful within the industrial control network. All right, so let's go back to our SCADA system and make sure that we're connected up to our PLC controller. So we'll go to our settings, connections, our edit. And again, 502, magic number. And we can see our light went to green. Those error messages down here went away. And so if we go back to our editor, we can see that it's there. And let's go ahead and hit run. And we can see this system up and going correctly. So this all looks good. We can see our fill chart down below is actually going up there. And again, in that chart, if we were to watch that long enough, we should see that stay between what two numbers? Does anybody know? They've been paying attention along the way. 2 and 8. That's correct, Rafat. So again, by default, our system set up for 2 and 8. We can confirm that over there on the PLC, that our bounds are set to 2 as a quote tank empty and 8 is our quote tank full. And yesterday we tweaked those numbers. That I think that's where you got those numbers from, Terry. But we have our alarm set to 1 and 9, and obviously in this particular routine, there's not much chance of those alarms ever going off. So, all right. So on our Kali box, we're going to go ahead and jump in there. And again, during this particular event, we have a Kali box on this network, right? So eventually we're going to work our way back out to the corporate network and try to break our way in. But for now, we're just trying to give you how you would do this man-in-the-middle attack once you broke into the system. So on this side, we need to shut off those two interfaces again. And then confirm that we have the right network. And we do on 2.5. This part is important because once we get into these later labs and be on the outside world, we kind of want to make sure we're not cheating and getting into the inside network directly. So, all right. Inside here, we are going to bring up our 192.168.1.10 8080, and this is just on the Kali box. This allows us to see our open PLC system. So we're going to bring that up here. Should be coming up. Now, I'm going to end up breaking this box out because the way this lab is written, you kind of want to do some things side by side. So I'm going to break that a little bigger, and then I'm going to make this screen as a whole a little bit bigger. And I should be able to set that to actual size. Okay, great. So again, we're on our Kali box. We're able to log in here, and we're mostly just doing this so that we can see this happening in real time. So if we go to our monitor tab, we can again see this kind of traffic happen over here. So we're just going to throw this off to the side for now. And then we're going to end up creating a new tab over here. I'm going to end up swinging this over here just so we can do a side-by-side. And we're going to log into our HMI, so our SCADA system. And we can see that that's there running that tank simulation as well. All right, so we're going to bring up our terminal editor here on Kali. Kind of let those be in the background there. I'm going to kind of shrink this down a little bit. There we go. And we need to get into our Modbuster app. And so this Modbuster app is just a simple Python script that kind of brings a few things together. You're going to manually do these in the future because obviously you may or may not have a Modbuster script to do this. But this is a good demonstration of how this would work. And so the goal is to put the Kali Linux VM. Let me pull up topology here so you can see. The goal is to put this Kali Linux VM between these two PCs. That's kind of why it's sitting over here. And the goal is that we're going to intercept traffic that's destined for the PLC to go to the Kali box, and traffic destined for the SCADA system is going to go to the Kali box and act as a man in the middle using the arc poisoning going through there. Oops, that's not the lab I wanted. There's my Kali. Okay. So inside of our documents folder, we have our encrypt Modbuster. Let's see, is there any other devices? Are there any devices that we can detect with a Modbus attack? Yeah, typically you would want to see this on your firewall going on, or you would see this on like an IDS IPS running within the firewall itself. That would be another way where you would see weird things go on. There again, the problem with most ICS industrial control networks is that they're very, very basic. The things we take for granted in our IT side of the house, we can't have that running inside of an OT side because it would put too much information on the network. And we cannot have downtime, right? So if you remember on the IT side, availability is kind of our last thing that we really care about. Where on the OT side, it's one of the first things that we care about and making sure that we have the highest availability. All right, so we're over here. We're going to take a look in this folder and we can see the encrypt Modbuster app. So we're going to use sudo python 9 3.9 and this encrypt. And again, I'm going to show you this kind of stuff under the hood as to what it's really doing, but this is a pretty cool little script that they wrote to do this Modbuster test. There we go. All right, and this was all written by Gideon. Gideon, again, was a PhD student. I forget the name of the school. I can find that out here, but he's working at Encrypt. And so Encrypt, if you guys aren't familiar with them, pull that up here. Is part of the National Center for Reliable Electronic Power Transmission. And so what these students were working with is they actually have a full-blown power lab at the college. And they are doing a series of different tests and trying to mimic different attacks. They have some pretty cool systems that allow them to mimic like power outages and power surges or blackouts, etc. And so when they're writing scripts and doing safety testing and things like that against them, it's pretty awesome what they can pull out with all the equipment they have there. Like I said, they have their own little full-blown data center as well as a full-blown power company running inside of there. And they're based out of Fayetteville, Arkansas. It's a pretty cool little group. On the student opportunity side, I just want to pull this up to see if they showed up anything. Yeah, it didn't show anything about their research there. University of Arkansas. That's I'm trying to remember exactly who it was under there. So yeah, at the University of Arkansas, they're doing a bunch, and they're really tied in with a lot of the industrial partners so that they could pull some of this stuff in there. And we worked with them a little bit in the past. in order to get this stuff up and going. Okay, sorry for the sidebar, but some people want to know where this content came from. And so on this side, we have a couple different tools that we can do in here. You'll see a full SCADA, a DOS attack. We can view the Modbus traffic raw, and a couple other options that we have. So the first thing we want to do is kind of look at the settings of this tool. We look at the 6, and we can see that our SCADA IP is set up for us with the correct MAC address. We have our Modbus IP address and MAC address, as well as the port, and then the default gateway, right? And anybody that's played with EtherCap, like what you were talking about there, Terry, that these are really the settings that you need. And so to get these settings, this would have came from the last lab where they used Nmap or Ruscan or something like that to try to figure out what's on the network, and then they can start grabbing this information to use on EtherCap. So this all looks good. We're going to end up using Q to kind of go back to the main menu. And then from the main menu, we're going to use number 5. And number 5 is just going to put us in the middle with ARP spoofing. And so if we hit 5, you can see that it's really just EtherCap under the hood with a bunch of settings all plugged in. We are currently doing ARP poisoning between 2.10 and 2.1, which allows us to sniff that traffic in between us and the SCADA system that's there. And we should be able to see traffic flowing in between there. So if we see this here, looks like this one's flowing. And so now what we want to do is see the traffic going between those. If we hit number 4, we can see this is the traffic that's flowing between the PLC and the SCADA system over here. That's how it's determining how to build this HMI between the two. So we can see that traffic kind of flowing out there. Works pretty well. All right, so the next thing we want to do is kind of watch the Modbus traffic, see if we can get a better detail of what that looks like. And this is just doing essentially raw packet captures, and we can see the Modbus traffic as it's flowing through there. Obviously, we would have to decode this in order to figure out what packet means what, but you guys are saying you've done that before, right? This is really just Wireshark, right? What we're looking for is to go into the function codes as well as the part in the data packet that we can go in and manipulate. So all of those Wireshark labs that we did here yesterday is really so that we're aware where that packet information is and what bits we need to flip through a script in order to tell it that we are actually wanting to write a 1 to that or a 10 to that or whatever we want in between. Everybody kind of follow along so far? Again, I know we have a wide range of background here, so I want to make sure I'm not talking up in the clouds that I'm able to work with. Okay, good. Okay. So the next thing we want to do now that we have this man-in-the-middle attack in place, which just allows us to see traffic as it's going through the network, is we're going to end up creating this DOS attack on the SCADA system. And we're going to do that by intercepting and essentially just dropping those packets, right? So our denial of service, we are just intercepting the traffic, routing it to null, and all of a sudden everything kind of stops. So if we come back here to our main screen, we're going to run a number 2, which is that DOS attack. Hit enter, and we want to tell it what we want to attack on this side. It's going to be that Modbus firewall. And so now EtherCap is running in the middle, and we can give it an option as to whether we want to block the traffic or turn it back on there. And so we'll press 1 in order to block the traffic, hit enter, and you'll notice over here on the far side that we're seeing some write raw errors. We're also going to see in our HMI that we kind of stopped receiving packets. Now the PLC is still running. We can see over here that this is still going to fall to a 6. There we go. So our PLC is up and running just fine. However, our HMI has completely lost communication with that PLC device. And again, we're essentially taking those packets in and kind of dropping it all together. Okay. So back on our Modbus screen, we're going to go ahead and press 1, and we'll press R2 to turn it off. And you'll notice the HMI snaps right back because those packets are now allowed to traverse through our man in the middle of the attack, and it can go on and keep picking up the values that are coming through here. And we can see immediately when it hit 2 on the tank valve, the water kept flowing, everything's going up as normal. That's a real simple denial of service attack that we can perform on the SCADA engineers that are watching these like a hawk. If we go back over to our SCADA system, in our case, we're still communicating just fine, so I won't worry about that. And so if we can take those packets, we can also intercept them and manipulate those packets as well. So now we're just dropping the packets, causing a denial of service, but we can actually end up overwriting those packets and doing whatever we want. So right now, on full to SCADA, when we run the number 1 here, you'll notice we're just writing random bits of data over here. And of course, if a SCADA technician sees this, they're going to think they're having a really bad day, right? So if the tank is, positive 24,000 or negative 1,000, and the water valve just keeps turning on randomly, they're thinking the system is going haywire. When we look over here at the PLC, everything is happening just fine. Nothing's actually going on. We're just fooling the SCADA system as to thinking that a bunch of random data is being sent that direction. We go ahead and hit Control C to stop that. The HMI immediately goes back to normal and is getting the information as it should from the PLC controller. So it's a really good visual representation of how man-in-the-middle attacks work, especially in this case when you're dealing with real life. Again, right now we assume this is water coming up in the tank, right? But if you put something, even water is threatening, but if you put something more dangerous in there, like a caustic chemical, or maybe this is the chlorine tank in order to supply the water treatment facility, you can immediately cause some pretty bad issues by messing with the HMI. Because at that point, the operator doesn't know what's going on. They could hit the emergency stop button, which is going to either A, stop the flow of chlorine gas into the water, which if anybody knows anything about water treatment plants, that's going to, at some point, cause an issue where you're going to have water quality issues. And so now you're going to have boil advisories and things like that in order to keep that water system and maintain its health. I wish I didn't know all that, but somehow I know all that through my dad. So, all right. So that's a pretty cool little attack that we can do in between there. We're going to go ahead and use Q to get out of this Modbuster tool. And so under the hood, that Modbuster app is really utilizing Metasploit in order to do some things, as well as EtherCap we talked about. It's also using some pretty simple rewrites within like a tables for us to drop the traffic. And then the injecting the random values and stuff like that is a real simple Python script that is taking those same packets as they come in, rewrite the values because we know where the header is, and then sending that information off to the HMI. But we can actually use straight Metasploit if we wanted to in order to play with that. So if we fire up our Metasploit console, and so how many of you get to teach or play with Metasploit in the classroom? Great. Good handful of you. Great. All right. Pop quiz. If you can name this movie. Anybody get this joke? Yeah, there you go, Terry. All right. That is correct. It was Jurassic Park. It's when old Samuel L. Jackson's trying to hack into the system and didn't provide the right password in there. So. All right, we are going to use the Modbus client that's available in the Metasploit framework. So use auxiliary scanner, SCADA, Modbus client. Okay. And so again, this is just a Modbus module that allows us to write data directly to a PLC controller. Yeah, that's right. It was the response to him typing in the wrong stuff. All right. Within this, we can use the show info. If you guys have used Metasploit, you know that these are the tools that you would typically use, or the commands you would use to set up the modules that you want to use to do vulnerabilities. So a show info allows us to see which values that we need to set in order to adjust settings on a PLC controller. Now, obviously, we had a simple tool called MBT Git yesterday, right? But as a hacker, this is typically what they would use as a module within, like, say, a Metasploit framework, because there's lots of other modules. And then they can use that to pivot and get access into other stuff. You can see down here that it's actually using the old Perl script MBT Git in order to play with some of that under the hood. So, all right. Those are our basic options. What we're wanting to do is see which options are currently set. So if we type in set, we can see that we don't have a whole lot of those set, but there are some variables that we need to adjust in there. And so to do that in Metasploit, we're going to use the set command in order to set these variables. So we have set our hosts, and this is going to be our remote host that we want to attack. So this would be the IP address of our PLC controller. And then from there, we need to set our port. And because we're dealing with Modbus, we are going to use port 502. And then the particular data address that we want to play with is going to be 64. That is setting the register for our high tank alarm. So let's play with that. Set data address 64. And our action is going to be doing a read holding register. So for now, we're just going to read what is currently at that data address. Set on a sec. And again, where I'm getting this information, if you scroll back up here, you can see the different actions that are available. So we're going to be doing this read holding registers and setting the specific data addresses on this side. All right. So with those variables set up in Metasploit, all we have to do is hit run, and it will run the exploit. And we can see that the current value for that particular address is set to 9, right? And that matches. We have this high tank alarm over here, and that is set to 9. If you remember, this QW64 translates out to data address 64 on Modbus, right? And that was part of that table that we kind of showed you in the past. So let's go ahead, instead of a 9, let's set that to 100, right? And so what that would do is make sure that that high alarm never goes off, right? Because the tank only goes from 0 to 10. And so if we set it to 100, there's nothing that's ever going to trigger that high alarm. So if we do our set data, and we know that from us writing the program here a while back when we went through and looked at that. So set data 100, set action, write register. And so now we can simply run our, we can see this over here, still set to 9. If we run our Metasploit, we can see it immediately changed that variable on our PLC controller to go up to 100. Sorry about that. I lost my screen over here again. All right. So that's pretty cool. We can use Metasploit in order to overwrite those variables. And then we could also cause damage to the tank system itself, right? So this didn't cause any damage. But what we could do is then tell it that we want to set a tank full parameter, which is currently 8, right? That we actually want to set that to something larger than 10, which would cause the tank to overflow. And so we could set that at set data register. I'm sorry, set data address 16. Again, that maps over here to this QW16. And we want to set data to be 15, which would be something larger than that. And then we could go ahead and run this exploit. And so now we can see this high tank side where the set point is now set to 15. And so obviously our HMI won't demonstrate this, but if we watch this start to fill back up, it will eventually not only exceed 8, and because we set a high tank alarm of 100, it's never going to trigger an alarm over here for the SCADA operator, right? They're watching these screens all the time, but they usually are looking for alarms and alerts, not all of a sudden this exceeding where it's supposed to be exceeding. So here we hit that 8 mark. The tank is keep filling. Now reached 9. So no alarm is going off. And hit 10. And so now we've not only filled our tank, we're exceeding the tank, in which case this is obviously going to continue to climb and kind of, quote, overflow at that point in time. So the good news is obviously this wouldn't quite work like this in real life because if it's a sealed tank, it would never overflow out the top. It would, or sometimes have an overflow. But what would be happening right now if this was a sealed tank? Anybody have any ideas?
It'd probably bust.
You got it, right? We're building up pressure now in that tank. So whether this was a liquid in this form, or if we actually have some pressure over here, in other words, this isn't just a valve, that this is more of a pump, that at some point we're going to build pressure in this system. And that could also be very dangerous and catastrophic on that side, especially if this was, say, chlorine gas, which is typically what you use in water systems to kill the bacteria, etc. This could be a nightmare for a small water treatment plant. All right. Again, even if it's water, we could still cause this tank to overflow in that case. And most water tanks at a water treatment plant are actually open. But if it overflowed down and doesn't have a waste containment type system, now all of a sudden you're going to end up flowing out this SCADA area, or flowing out the treatment facility. And so a great example of this in real life that happened, my father was getting a phone call that water was running out of the electrical panels over at the water tower. And we were trying to figure out what he was talking about. So we got over there, and sure enough, water was literally flowing out of the electrical panels. And what had happened was a seal had failed on one of the motors. And so water was trickling down the side of the motor. And because it followed the power cord coming from the motor, it actually filled up the conduit under the ground and through the concrete, all the way to the point it backfilled into the electrical panel, and then obviously started flowing out the electrical panel. So one, bad design that came through there, but it had been like that for 30 years. But a simple little chaotic piece, like if we had kept that motor running forever, which is kind of what happened in this case, because that seal broke, we could actually cause this as hackers breaking into the system, eventually causing something to fail to where it's a catastrophic fail like that. All right, great. So that's the end of that lab. That shows us a little bit of what we're going to attempt to do once we get down into the actual network. Yep, that's a great reference there of the different function codes. Thanks, JB. All right. So now that we know what kind of attack we want to create, we're going to get into this pen testing a corporate environment. So again, we're going to put on our IT hats now. And our job is to go through the corporate network, look for loopholes. And once we find a loophole in the corporate network, see if we can't worm our way down all the way in. Right now, we just are pen testing a standard corporate environment. That's it. So this one's going to take a little bit longer because there's quite a few VMs that are extra in this side. How are you guys liking the lab set so far? Is this something that you would like to implement in a class? Do you see the tie between IT and OT? Great, great. And again, those first couple labs are something that you could just take and put into a small class that is focused on industrial control systems. So if you don't have material for PLC controllers and SCADA systems, et cetera, those first couple labs, first 6 labs are really good for trying to just inject that in there. And then, of course, labs 7 through 14 are starting to get how you would marry that IT into the OT environment. So this was written without needing a textbook, JB, and that's kind of why it goes into some detail in the beginning. As far as this latter piece, there's a couple good ones out there about pen testing ICS. Let me see if I can find the name of that book.
I've been looking at some on Amazon.
Yeah, there was a good one that I used that was kind of the basis of a lot of these tests that I went through. I'm trying to remember what that was called.
I mean, we can wait till this afternoon, during
Oh,
prime
here it is.
comment time.
No. That's a good time because if people are looking to use it, this would be a good one.
Go ahead.
Sorry, this was the main book that I kind of based a lot of this lab set around, which was pen testing industrial control systems. They have a way for you to set up your own environment and kind of get the VMs up and running. In this case, I kind of took that as a basis for it, but then I heavily modified everything to make it work in the NetLab environment and also update some of the tools and backends and things like that to more modern day. What were you saying?
Any class we have around here, we have to have a textbook.
Yeah.
So that was why I asked. Thanks. Appreciate it, Jason.
And there's the ISBN numbers for those too, if you guys need them. Yeah, we used to have that around here too, where got to map to a textbook. Now they do the opposite. Now they pay us to not use a textbook. So it's the world of academia is different every day, right? I just show up every fall and see what this year is going to bring. Okay, let me get this pulled over here. All right, so I do want to kind of skipped over that a little fast. Sorry about that. Let's refresh this. I'm having a problem with my browser. It's nothing to do with this network. It's time for me to wipe the machine before the fall semester and get everything up and going again. So. All right. So this lab is kind of to help us walk through the eyes of a hacker that's gained access to the enterprise network in some form or fashion. And they're going to perform some information gathering to set up that future attack. It's meant to be the first part of the series of exercises that will take you on a journey as an ethical hacker who carries out an attack on a PLC system. So after performing the information gathering exercise in this lab, you'll be able to actually perform an attack on the PLC as an ethical hacker in the following labs. So all we're doing in this lab is trying to gain some information about the computers and the users on the enterprise network. Again, we are not at the ICS side of the network yet. So this is more of a IT side of the house where we're trying to collect information. All right. This just gives us a note here that you will, on these Windows workstations that you're going to see in here, we're using Server 2019. Normally, you would see a Windows 10 or 11 or even a Windows 7 type workstation. It has no effect on the lab that are in here. And the reason for that is to comply with some licensing on Microsoft side. So when you're using this online environment, we are unable to use desktop licenses. We have to use server licenses. And so that's the only reason you're seeing that here. All right. So we're going to get fired up on the Kali side. I'm going to go ahead and undock this off to another window for us. Now, how did they get access to the corporate network? You know, this could have been a phishing system. It could have been a spear phishing. You know, there's all sorts of ways to get that compromised on the corporate network side. Hopefully, the IT has done a pretty good job of blocking those kind of things, but we all know just how easy it is for people to fall for phishing attacks and any other ransomware attacks, things like that these days. It's big business and getting that kind of access. So this one, we're going to adjust the networks. Instead of disabling 1 and 2, we're actually going to do 3 and 2, as we are now on the Kali network is now up here on this 172 enterprise network, 172.16. And so we want to make sure that we have access to that. And we can see that we are at 172.16.2.5 for this case. So we can go ahead and do a simple scan on our network. And because this is a Windows network, there's a couple of specific utilities that make this a little easier to do. So if you guys are familiar with NetBEUI name servers, that allows us to gather information about Windows systems that are out there. And so there's a tool called NBT Scan. An NBT Scan, we'll just go ahead and hit the local network. And we can find that there's 2 other PCs on this network. Now, obviously, in a real corporate environment, we would see quite a bit of ones go through there, right? But we do have this WinDC on 2. And so this would be a good thing to kind of build into a CTF, is to have them gather this information. 172.16.2.2. And that is our WinDC. In this case, that'll end up being our domain controller for our network. And then we can see we have a corporate workstation here. So 172.16.2.4. All right. And we got our MAC addresses and some other information that we can gather from that. We could do this also through an Nmap scan, et cetera, where we could pull this kind of information going on out there. All right. There's a couple different tools that we can use. One of them is called enum for Linux. And so if you guys are familiar with that, enum allows us to enumerate a work group within Windows. So it allows us to gather more information about what's going on. And so we want to gather more information about that domain controller, right? That would be the first thing that we as attackers would want to go after, because if we can compromise the domain controller, we kind of own the network at that point in time. So we're going to start there to see if we can get in there. And so this tool is going to give us a little bit of information. We're going to kind of scroll up here and see all this information that it comes out of here. So one, we can see that there's known usernames on this particular system, and this is just rolling through things that Windows basically advertises. So some known usernames are going to be administrator, guest, KubeGet. These are kind of like service level accounts that are on Windows systems, particularly domain controllers that you would see that out there. The big piece of information we got is that they are all working in the work group of NetLab, all right? So the work group name is going to be NetLab. You know, by default, does anybody know what the Windows default is? What the work group name is? Work group, right? There you go. Good job, Michael. And technically correct. Yes, Terry's technically it is all caps work group. Yes. All good. All right. I throw that in there because remember, there is a quiz at the end of this class, right? I don't know if that one will be on there, but that may be a good one to throw into our CTF or something like that along the way. Great. Let's see what else we can find in this system. So we're going to scroll down here. Doesn't look like we can get much other enumeration coming out of it. For the most part, we're just not having enough privileges to get information out of it, right? We got access denied on most stuff that we would use for enumeration. That's our nice little SMB. So we would have to have some to figure out the password policy. We got to elevate our privileges as we go through there. Right now, we really just don't have access to much on this system. Let's go ahead and run it on our corporate network one, or our corporate workstation. And if we scroll back here, where's 4? There we go. We can see that we got some of those same usernames that are through here. We again see that it's all running on this particular work group. But we can also see as we scroll down here that we really don't have much privileges or access on those systems. So we gathered a little bit of information, but we need to really kind of exploit that NetLab domain to see what's going on. So to gather some more information, we're going to need some other tools that'll help us get through there. And one of the good ones that's out there, if we go out to our downloads folder, we can see that we have this users.txt file, right? And so with that information, we want to enumerate or determine that if there's any users that may exist on a network. And the reason this is important is in the OT side of the house, everything is almost always left to defaults, right? So most vendors are going to have basic users that have logins. So it could be something like SCADA 1, SCADA 2, or SCADA Tech. Those are the default logins for everything. And then you would obviously have options for passwords there as well. And some of those could be left at the defaults in that regard. Again, does anybody remember why security isn't important on the OT side of the house? What replaces security or confidentiality rather in a ICS network? Remember our CIA triangle?
Yeah, but I can't remember the word that's over on the left side.
Yeah, Greg got her figured out. It's safety, right?
Yes.
So you guys are more worried about safety than they are about confidentiality and passwords and usernames. Like, it just doesn't matter to them. They really care about the safety side of it. So
just remember industrial OSHA safety.
You got it. That's exactly right. Because little mistakes usually in an ICS type environment become really big problems. Loss of life is a very common thing if there's accidents that happen in that realm. So we definitely want to pay attention to what we're doing. So what this allows us to do is look at this downloads folder, and you're going to see this user.txt file. And this is really just a compiled list of all the common SCADA usernames that are used for multiple vendors. And we can take a look at it here. If we do a word count on that file, there's about 69 different unique users from all the different vendors. This is a common file that's out there on the internet. It's not like it's something only to this lab environment. You can do some Google searching and find all these. As a matter of fact, that's how I built this user text file, was I went out and found all the common usernames. There's also a distribution that's kind of been out there that is with the Kali Linux. As you know, there's lots of word lists on Kali Linux. I don't have to explain this to some of you that play with Kali quite a bit. But they're also excessively long, right? And what we really care about right now is the usernames. So if we do a little bit on that usernames, let's do a users.txt with a cat, and we can see some of these common usernames that are going to go through here. So we see things like operator 1, SCADA user, SCADA 1, My Turbine is a common one from another vendor, simple user, simple admin numbers, installer, even, just straight user Siemens as they go through here. A lot of what I saw and when I was writing this lab is simple ones like FTP user. Again, they're not using any security or clear text. They're just trying to get firmware on these controllers, right? That's it. That's all they use the Ethernet for. However, they can still make changes with that Ethernet interface too. So it's pretty common to get some very basic usernames through here. What we want to do is use a tool that's really good for Active Directory, and it's called KERBROOT. And the idea behind that is it will quickly try to brute force and enumerate any valid Active Directory accounts on the systems. And it does that through Kerberos pre-authentication. And this was pretty common in older Windows operating systems, that the pre-authentication was set up for you to be able to communicate through there. A lot of times when you're using this older software, you have to be able to communicate out there on the network. So in this case, we want to use KERBROOT to see if any of these usernames that are so common happen to live in the Active Directory side. So let's use our KERBROOT. And we're going to use user enumeration. We point to our user's text file, and we give it the work group that we want. We found that in the last information there. And we point to our domain controller so that it tries to use that to attack. And it goes through there and says it tested, and we didn't get any results there. Well, I fat-fingered the domain controller, so let's try that. And sure enough, through a little bit of brute force, we can see that there's an administrator account out there, and there happens to be an operator 123, right? Again, these are common username and passwords. They weren't just made up for the user environment or for the lab environment. So I'm going to write these down so I make sure I keep track of these different accounts. We have administrator. We have operator 123. Great. So that at least tells us that there's these accounts on the Active Directory system. Again, we don't have passwords. We don't have any other information. We don't know what systems that they're allowed on. We just happen to poke the Active Directory to see if these are actually accounts. So the next tool that we want to play with is called Impacket. And Impacket is used to help determine if any of these newly found users happen to have that pre-authentication disabled. Again, Impacket is just a collection of Python classes that work with network protocols. And there's a couple different script types that you could use. Again, it's pretty common for this pre-authentication to be off in some instances where you can't use it to authenticate with Active Directory on older systems. So the command we want to use is Impacket. And we are going to get np users netlab.local, and we want to try that administrator account right away, right? Because if we can get the domain admin account, again, we pretty much can compromise and do whatever we want to do. So let's try 172.16.2.2, and we're going to try to authenticate with no password. As we can figure out, this particular account does not have pre-authentication all set up. Again, if you're not familiar with Kerberos, the pre-authentication means if they're already on the system, they're already kind of authenticated, like they have a ticket in there. You can kind of think of it like a cookie or a cache within the Active Directory setup. And this particular user does not have that option available. So this one, in this case, does require pre-authentication on the system. We're going to run the same command again, but we're going to take a look at our operator 123 and see if any of those happen to have that option turned off. We can see that one also requires oh, there we go. We got a ticket on number 2. And on number 3, that option's not set. So for operator 2, what that gives us is a Kerberos ticket. And that Kerberos ticket is basically like a pre-authentication type site, but it allows us to use this ticket to authenticate up against the system. And it returns this big long hash that comes out of there, right? What we want to do is try to copy this hash And then we're going to use some basic tools in order to try to see if we can't break that hash. So the first thing we want to do is create a new file here in our downloads is fine. And we're going to call it operator2.hash. We're just going to paste that one in there. And so if we cat our operator hash, we can see that we created a little hash file with all that information inside of it. All right. From there, there's lots of tools to try to break hashes that are out there. The most efficient one, best one anymore, is Hashcat. And we can use Hashcat because it works well with CPUs. It works well with even GPUs if you really want to go fast. And it's been around for quite a while. Before that, does anybody know of any other tools that are good for breaking hashes? Where's all my Kali people at? So we would have had tools like John the Ripper would have been another common one to break a lot of hashes. But Hashcat has kind of taken over in popularity in that regard. All right. So with Hashcat, we're going to try to run that and see if we can brute force that password. And you'll notice on a brute force, it takes forever for us to do that, right? What we're going to do is, like I mentioned before in Kali, there's lots of word lists available. I don't know how many of you have played with those word lists, but in the user share word list directory, there's all these different files that you can use. And in what these are essentially known usernames or sometimes passwords that go through there. So for example, if we go into Metasploit and we look at the HCI Oracle passwords, this is a common list of passwords that are available for that particular system. And there's quite a few of these type of files out there. Obviously, you want to use these first because password dictionary type attacks are a whole lot easier to use. For example, if we cat our passwords file in here, we can see a bunch of different passwords that go through there. And on those, it's really nice to kind of do a word count to see just how many are in that list. And in that case, there's 88,000 passwords that are available in that simple list. And Hashcat would just sit there, calculate the hash for each one of those, and then figure out whether or not it matches the one that we have. If it matches, then we found the password that's in there. We're going to go back, and in this main word list file, you're going to see this one called RockU. And RockU is a pretty big one that's sitting in there. If we do a word count on RockU, we can see that there's just about, 14 million, 14,344,392 passwords available in that one. So lots and lots of passwords for us to go against. And lots of time to test all of those, but it's a good chance of us catching some of the common passwords that are out there. So what we want to do is use our, forgive me, looks like my Chrome just decided to go ahead and pause. We never did take our break at 10:30, should we? Hopefully everybody's still there. Is my computer fully crashed, or is it just my browser that died?
Just your browser.
Okay.
You can still hear you.
All right. Well, let's go ahead and take about a 15-minute break here while I get everything up and going, and then we'll kind of break here again at lunch, but that'll give me a chance here to get this up and going. Sorry about that. Again, I'm horrible on breaks, so by all means, somebody stop me. Just recording back up too. There we go. All right, so where we're picking up is, remember, we have this RockU file, and we're going to use that along with Hashcat to see if we can brute force this password, in this case, perform a dictionary attack, and see if it happens to match any of the passwords for that particular user. So our sudo hashcat --force -m, and this 18200, that is the mode for Kerberos. If you do a --help, you can figure out all the different modes you can set with Hashcat. That one in particular is for Kerberos. So we're going to point it to that little hash file that we created. And we're going to point it out to that word list that we had there. Now that command's going to fail. I can tell just by looking at it because I had moved into the word list file. So let me get back where we were supposed to be. And I can remember where I was. I believe it's in downloads. There we go. There's our operator 2 hash. So now I can run that command. Tab completion worked great. All right, and so Hashcat's going to do its thing, and of course, you know, nice. In this case, it seems to be an AMD EPYC processor, so there's a little bit of power behind it. If you're running these on laptops, desktops in the classroom, you can do a pretty good amount going through there. So I'm just going to extend that here, even though we should be having plenty of time. Like I said, this is always fun in the classroom, having students crack passwords and find different ways to get through there, and it kind of gets them up and going, right? So in this case, it's a little common, more than it probably should be. But this operator 2 happens to have a password of password 2. So we'll jot that one down. Now, obviously, there could be more complicated passwords, in which case we can still use a much bigger, you know, this one had, what, 14 million passwords that it could have been. And the chances of it being on one of those, because, again, they're using defaults, right? In the ICS network, they're not all about making sure they have 20-character passwords. As a matter of fact, some of them systems can't even handle 20-character passwords. That's not their forte. So we want to make sure that we use some of the defaults as a first line of testing. So now that we have that password in there, that gives us a little bit of information. And so we're going to use those credentials of operator 2 in order to gain some more information about the domain controller, right? We don't know what permissions that user has. We're just going to try to use it to log in like we're operator 2 and see what other information we can get. So we have Impact again, this tool that we used before, and we're going to try to get all the AD users and list them. So by default, usually you can't list all the users that are in Active Directory, right? What we tested before was using kind of a way of seeing if any of these usernames existed, but we couldn't actually just dump the table of all the users. Now that we have some credentials, usually we're able to do something like, you know, list all the users in the network kind of thing. So we're going to do our operator 2 hash dash DC dash IP, and we're going to point that out to our Active Directory server. And it should prompt us for a password. And since we know that, we'll type that in. In this case, I got a bind error. I probably typed something in wrong, so let me just type that in here again, make sure I didn't miss a step. I should get that. Try that again. There we go. I just didn't type that password incorrectly. So what did we get about this? Well, we get some additional accounts that are possibly out there. And in this case, we got the Kerbrute password, the KRBTGT. That's another account that's out there. We'll notice on that one that the password was set, but there's never been a login in there. So in the world of Windows, that more likely means that that's just a service account that nobody's ever getting in there. But we do find one that's pretty beneficial, and that one looks like lab.da. And so if I had to guess, that's more of the lab domain administrator account. And so ultimately, we're going to try to figure that one out as we go through. All right. So with those credentials of operator 2, we've at least listed out the type of users, or the user list here gives us a little bit more information as an attacker of what we can find. Now what we want to do is use those same credentials of operator 2 to see if we can get any more output and see if there's any other service accounts that we could try to attack. So let's do Impact. And this time we're going to get our user SPNs, our service accounts. Pass in our password. And so thankfully enough, we get a look in here and we can see that there's some other service tickets out there. And in this case, server or operator 3, which is part of that SCADA network, seems to have logged in and has a ticket there. And so we were able to download what's called the SPN, or the service principal name. And that led to acquiring another one of our hashes. This is a different hash format. This one is what's called a ticket granting service. And again, this is part of what Active Directory offers. And so you'll get this hash out of this ticket granting service here. So we're going to go ahead and copy this one out here as well. Now, the cool part about this one is it's the password for operator 3. However, we're going to use it in a unique fashion here. So let's look at our downloads. And we're going to create a new file called operator3.hash. And we're going to paste this one in there. Oops. All right. And now that we have this one, we're going to need to use the ticket service in order for us to figure this one out. It's a different mode in Hashcat. So we're going to come back up to our Hashcat command, and we're going to change this to the ticketing service. And we'll pass it the same operator list and see if we can break this one as well. Let's see here. So my problem is I didn't set that hash correctly. So let me do this again. RM operator 3. Nano operator 3. This is probably because I hit enter in there and it added an extra character, would be my guess. Nope, that's 2. Let's try that again. 3. There we go. All right, let's try that command. Must not have grabbed the right full thing here. So let me get this back here. Give me just a second. Guessing I missed a character when I did my copy. We're going to separate. I'm typing something in wrong here. Let me give a shot. See what I'm missing here. Oh, I got the wrong mode in there. That's what's going on. It's 3.1, not 2.1. There we go. Sorry about that. So again, we're using Hashcat to use a different mode. First one was a Kerberos hash that we're going through there. Now we're going to go attack a ticketing service that's available in the Active Directory and see if we can acquire this one. So this attack, again, is against operator 3, and we can see we ended up cracking it, and it didn't take much because we're doing an operator or a dictionary attack. Now, obviously, we could still go with a standard brute force and just trickle it a little bit over time. And as you know, most attacks don't happen overnight, right? They're usually months to try to pull off an attack as you go through there. So we want to, one, maintain our attack or maintain our access to the system once we got access. But we will usually like take this hash out and go crack it offline in our own systems, whether we have really powerful ones to do that or we just have nothing but time in order to sit there and try to break that password. Obviously, in most Windows areas, you want to crack that within a reasonable amount of time, especially if they're set to, reset their passwords every 30 days, 50 days, whatever their policy may be. And of course, we don't know that policy. So we're really trying to make sure we crack it in the short time we're there. All right. So in this case, we were able to crack this one. And of course, it wasn't exactly a super famous password. So for operator 3, the password is password 3. and we were able to get that through there. All right. So now with that, we want to take a look at those two credentials. We have operator 2 and operator 3 credentials. They don't really do much for us yet, but we at least have some credentials to play with. We need to try to figure out how we're going to go about getting operator 1's credentials, right? So far, we really haven't seen anything going on there. And so we're compromising the network. We don't really have a way to get operator 1 at this time. So what we're going to do is see if we can't listen in on the network traffic here and see if we can't capture it going out and doing that kind of thing. Yeah, we could use phishing. We could use all sorts of things to try to capture this operator 1. In this case, because we have somewhat compromised the system and we have access, we're just going to do a pretty good job of listening on the network and seeing if that passes through. So let's use a pseudo responder. And responder is kind of like TCP dump. It's just a way for us to listen to very specific traffic. And in this case, what we're trying to do is listen to responder. And what it does is listen to the network and tries to collect any kind of NTLM hashes. In other words, people trying to log into Active Directory, we're going to try to steal those hashes on the fly as they transmit across the network. So we've got this fired up. And at this point, as a hacker, we would just sit there and wait and to see if we would ever get any NTLM hashes across it. In our case, we're thankful that good old operator 1 shows up for work that morning. And we're going to go ahead and have them log in. And it turns out the password is password 1, but we don't know that yet. So that operator just logs in for their work. And after they get up and work, they're going to go ahead and open up their browser because the first thing they want to do is go check that SCADA system or do something on the network. In this case, we're just going to open up a network and go out to test. And test doesn't really do anything, right? They're just trying to go out and browse the internet and do some things here. In this case, nothing really happens, right? We don't see anything happen. But if we go back to Kali, because they went through and were trying to be an authenticated user on the domain, we can actually see that when they tried to connect out to the internet, they used their credentials of Active Directory, and that's common in an Active Directory type scenario. It then sends that hash to authenticate that user on the network. And in this case, we listened enough that we were able to dump the NTLM hash for that operator. Now, we can't hack that. We can't do anything with that, but we're going to start at least grabbing that hash from that operator. So let's see if we can do that. We're going to grab everything here to our zeros. Copy that out. And we're going to create our oper1 hash, right? So we've done here. We're going to go ahead and break out of that. And let's nano our operator 1 hash. And we'll dump this in. Again, it's pretty scary, the tools that are out there. Yeah.
Jason, if there are any batch files associated with the login, will it capture that as well?
It would, yeah. It tries to find anything on the network, and it's specifically just, in this case, looking for NTLM hashes to show up somewhere. So it's kind of basically doing a TCP dump on the network, floating everything through. Obviously, this would only work like if you're in a hub or you have a man-in-the-middle type thing, so you're sending traffic in, that kind of stuff. All right, so we have operator 1 as a hash. And of course, we want to go through and try to crack that using Hashcat. So let's do our sudo Hashcat. And this time, the mode for this is going to be 5600, which is NTLM. And if any of you have ever worked with Windows systems and things like this, if you get physical access to the system, you can use bootable CDs like Huron's Boot CD is a really good one I've used in the past. You can log into that Windows system from a boot up and just dump the password hash tables out of there. And then from once you get those password hash tables, like this one, you can then take them offline and go password crack those with Rainbow tables or Hashcat and really powerful GPUs, things like that. We did that a lot back in my early college days. We were able to find quite a bit in that regard. So we're going to end up still using that same password list to see if it happens that this one is in there. And at the end, we're going to end up finding out that the super secret password that's in there obviously is password 1, right? We know that from when we logged in as the operator. But now as the attacker, because they logged in on the network, we were able to steal the hash. And then from the hash, we could go ahead and deduce that that password is in fact password 1. So we now have 3 accounts that we have compromised: operator 1, operator 2, and operator 3. There's a couple other accounts that we haven't touched yet. There's an administrator account. There's the Kerberos service account, but we've also seen that that one never got logged in. So the chances of a real password being set are pretty slim. And then we have that lab domain administrator account, so lab.da. And that's really the next one that we're going to try to attack and see if there's any way we can fish that information out of the system. And it turns out we don't actually have to ever figure out what that password is, because we're going to use some other cool tools for that. So that's the end of this lab. And then we're going to go ahead and break for lunch. And then when we get back from lunch, we're going to take on labs 12, 13, and 14. And again, those are significantly longer labs, as you're going to have to start setting up ways to get clear down into that PLC controller. At this point, we're just doing standard IT, ethical hacking, trying to find our way into the corporate environment. We at least found a way in. We found some couple user accounts. Whether they're useful or not, we don't know yet. But we at least have some username and passwords. We could also get those same style things out of like phishing attacks. We could get those out of several different ways, right? This is just one way of acquiring username and passwords. Let's see. So did the lab include the hash ID or the hash identifier to make people know that they determine the hash type before entering the code number after -m? Yeah. So in the lab itself, it tells you which mode to use, but it also lets you see all the modes that are there. What's really cool is there is a hash identifier tool, and so you can actually use, yeah, like what you were talking about. And so it ends up telling you how to, or which one this ends up being. Yep. For the sake of time, we didn't do that in these particular labs. I'm showing you how to use hash identifier, but that's a pretty cool tool to use too, Terry. Matter of fact, I think we used that in a earlier one, didn't we? I think when we were working with the Wireshark stuff, I think we used that. I could be wrong, but I thought maybe we did in there. So. All right. So again, we're going to break here for lunch. We look back at our time sheet. Looks like we are at lunch from noon to 1 again. And while I'm there, is there anybody I missed in the check-in sheet for the AM side of today? So I think Ken Gardner is the only one that was here yesterday that didn't show up today. Okay. And for David, I don't think I saw him either. Okay. Yeah, you're fine, Shaw. I got you marked off there. I saw you bop in. Not a problem. Okay. We will see you back after lunch. And there we're going to go, like I said, through the rest of those labs. And then I'm going to give you guys access to some ethical hacking stuff that you could go and kind of play with a little bit and see if that would be useful in the classroom as well. I kind of mentioned that here, but I'll get you guys some lab access to that. So we'll see you back after lunch. I wanted to do it this summer, so it should be good.
It's good to know. I have 2 administrators on our campus, not me, but my colleagues Sherry and Mary are responsible. So hopefully they're connecting with Mike. And
Perfect. Yeah, on the weather side, we get both of your guys' extremes. That's being smack dab in the middle has its faults.
Wait, remind me, Jason, where are you from?
In Kansas.
Oh, all right, yeah.
So we're on the side of 103 and 50% humidity, and then this winter we'll get the foot of snow, 18 inches of snow, that kind of thing.
For you trivia nerds, Kansas is the centralmost state of the contiguous United States.
Yes, sir. And I'm actually from like smack dab in the middle of the Kansas as well. So
You're right in the middle, buddy.
we're about 30, 40 miles from this direct geological center of the U.S.
Yeah, that's funny.
All right. Well, hopefully we didn't put everybody to sleep here in the morning time and keep everybody active here this afternoon. I'm going to wait to take attendance here and then we'll get rolling. Start marking some people off so I don't forget. Let's see here. There we go. No, she was just here. I'll come back. Pause. All right. So last lab, if you recall, we did a little bit of pen testing on the corporate network, and we were able to gain 3 different users. We have operator 1, operator 2, and operator 3. We found their passwords by cracking various hashes that we could find on the network. But we do still have this lab DA account that we don't have any information about, or the administrator side of things. So this time around, now that we've gathered that network credentials, we're going to be looking to try to gain some shells or do some privilege escalation. And then once we get into some system, we need to set up some kind of command and control center so that those victim machines will always report back to us. Even if they reboot, do whatever they're going to do, they're always going to report back to us. That also makes sure that we don't have to maintain a connection in, that they're actually setting up a connection outbound to us. And as we know, as IT administrators and such, that we focus heavily on inbound ports and inbound traffic, and we forget to make sure that we are blocking some outbound traffic that would show that maybe we have compromised or something like that. So we're going to end up creating a shell on the remote system. We'll set up that command and control center, and then we're going to use privilege escalation to try to see if we can't gain more access on those systems as we go through there. So we're going to start off with the Kali Linux box. And while we did that, we want to use some shells and play with some shells in there. And so there's several different tools you can use. This could be a little bit more of the Metasploit that we played around with before. Because we're working in this Windows environment, there's a pretty cool one called Evil WinRM, or Evil Windows Remote Management. And so Windows Remote Management is a common tool, right? We use Remote Desktop to manage things. Administrators will use Remote Desktop to get into servers. And things like that. So we're going to use a console that's meant to help exploit some of those systems and some of the vulnerabilities that are in some Windows environments. And so this one, again, we'll use the Windows Remote Management Shell. It's been kind of optimized for the hacking and pen testing environment. And it'll allow us to figure out some trouble tickets that have been set up by an assistant, and the technician handling that ticket forgot to actually disable remote desktop. So in this case, we have the administrator on the WinDC side of things is using remote desktop into this corporate workstation. They were using it to troubleshoot issues and that kind of thing. They just simply forgot to turn it off when they were done. And we're going to try to take advantage of that remote desktop session. So on the Ethernet side of things, again, because we are working on that corporate network, we want to go ahead and disable 2 and 3, and we can confirm that we have the right network by doing a nice IP add. Whoops. And we can see we are out here on the corporate network at 2.5. All right. So the first thing we want to do is to try to create a shell into one of the systems. And so this will be like either the DC controller or even just the corporate workstation. We're going to try to log in with some of the credentials we have there. And we don't want to necessarily log into remote desktop. Does anybody know why a hacker just wouldn't want to jump into the remote desktop side?
It logs out whoever's logged into the system, doesn't it?
Yeah, you got it, right? So if you're familiar with remote desktop, you go to log in, and if you log into a remote desktop session, it's going to kick them out. And it's pretty easy to detect that you got something going on at that point, right? So if they're calling up their administrator and saying, hey, man, I'm getting kicked out after I log in several times, it's pretty obvious we don't want to use that side of it. So, yep, you're right. And yeah, Mike, we don't want to get caught, right? The whole goal is to not get caught. So what we're going to do is basically the equivalent of like a SSH into the system, right? We want to be able to get some kind of just console command terminal window into that system. And obviously in the Windows side, you typically don't have SSH open like you would in the Linux side, but we do have ways to log into the terminal shell. So we're going to use Evil WinRM. And again, this is a package that you can get in there. And on the -I, this is going to tell us where we want to attack. And we're going to go after that corporate workstation first. And we're going to try to log in as operator 2. And so what we'll find out there is that it's trying to establish a connection. And sure enough, this user is a valid user on this system. Now, we could try the other accounts. We may get blocked or whatnot. But this particular one gives us a PowerShell command and dumps us right into the documents folder on that desktop, right? It's pretty cool to have this up because then we can set up some backdoors. We can set up things where they connect back to us, etc. But the whole deal here is because they have that remote management service turned on, which again, lots of administrators will use in order to, create trouble tickets or solve trouble tickets. They just got to remember to turn it off, and that happens. So for example, in that Florida case, and some of the other ones we demonstrated there, they had an old VPN that was still alive that allowed the service technician to come in. They simply forgot to turn it off when they were done. Once those credentials were compromised, the VPN was still up and going, so it allowed the hackers to just come right on in. They didn't actually have to break anything. They pretty much left the keys there by leaving the holes in the system. So now that we have this shell and we can at least remote into this FAR system, and we can do things like dir and see what's in their documents folder. We can go back a folder and see what's all in there. So we can see a typical Windows documents folder or the file system in there. We could go to, like, say, the desktop, and we could do a dir, and we can see there's a Chrome on the desktop, things like that. So we at least know that we're on this FAR corporate workstation. But in order to get them to connect back to us, we need to set up some kind of PowerShell on this system and run a script so that we can get it to automatically come back and contact us all the time. So we're going to create a new tab. We'll leave this connection open. And it's really good to stay organized up here when you're doing attacks and such, right? So I'm going to go ahead and undock this because a lot of our work is going to be in the Kali side. And for the sake of visibility, I'm going to adjust this just slightly so you guys can see a little better. Okay. And it's really helpful if we rename these tabs, right? Because you can forget what tab is what and where we're going through there. So we're going to rename this session. And we're going to call this Netcat. And how many of you have played with Netcat before? At least 1, 2. Okay, great. So Netcat basically allows you to set up your own little server, so to speak. It's a great way for testing different services and seeing if you get headers back or something like that. You can set up your own like little ports that you can set up your own little protocol for talking back and forth to one another. And that's essentially what we're going to do on this side. So Netcat is what we called this one. And what we're going to do is set up a real simple system to kind of come back and have it communicate back with us. We're going to go ahead and rename this session here so that we can call that Evil WinRM. Again, it's just helping us stay organized so we know what tab is what. And so on this Netcat side, we're going to do Netcat, which is NC. And then we have NVLP, which basically says numeric IP addresses, don't do DNS resolving. V is going to give us some verbose output. L is for setting up listening mode so that we can listen for connections coming into us. And then P is going to help set that local port. So we want 4242, and we usually just pick a non-standard port. Does anybody know why we would pick a non-standard port here? Less likely to get caught in some cases. We could set it up on port 80 if we need to bypass a firewall, or 443. There's nothing that would keep us from running it on those sides. And we could directly connect back into whatever port we want. It would take a higher end firewall, say, for example, like a Palo Alto that's actually looking at the application and not just the port traffic and what port it's across, but actually dissecting the actual application running across it. And that is why you would use something like a Palo Alto or something that can go at that deep level, because then all of a sudden it would say, hey, you know, yes, this is port 80 traffic and we allow it, but you're doing Netcat over this, not typical web browsing. And so that would be something that could block there instead. So we have this port listening on our Kali Linux box. And what we want to do is kind of set up a script that's going to tell them to connect back to us. So we're going to create another shell. And in this particular terminal, we're going to go ahead and call this one script, just so we can, again, stay organized. And we'll go into our documents folder. If we do an ls in there, we can see we have this little PowerShell command called myshell down here, right? And so if we cat myshell, we can see it's a real simple PowerShell command. It just says, here's the IP I want you to connect back to. Here's the port number. It's going to set up a simple sockets connection, TCP client, set up a stream, and then we're going to be able to send bytes across this stream. And in this case, it's very simple ASCII text that goes through here. It allows us to remotely connect and kind of sets up a remote shell connection. Very, very basic, very, very simple. These days, this is something that you could have AI help build you too. So, you know, you used to, as a hacker, you would have to have all these different scripts and things built out for you. Today, you could build that in 3 seconds with, you know, an AI and tell it, here's what I want to do. Here's the information. Write me a PowerShell script to connect into that system. And away it goes. So we see everything that's going through on this side. We would want to potentially change these IP addresses and port numbers if we need to. In this case, this is what we actually want to do. But what we want to do now is get this little file sent all the way back up into our remote system on this side so we can execute it. So if we go back to this terminal, we can type in menu, and this brings up our Evil WinRM menu. So yes, even though we're remotely connected to the system, remember on the Kali Linux side, we still have this Evil WinRM shell that we have access to. And one of those options we have is to be able to upload. And so what we want to do is upload from our Kali machine up to this system that PowerShell command. So upload from home, Kali, documents, by shell, ES1, enter, And we can see that file got uploaded successfully. Now, in this case, because we're in this desktop folder, it's probably not the best place, right? Because if I do a dir back over here, I just put that file on their desktop. They're probably going to notice that. So let's go ahead and remove that file. There we go. And once we're back here in this home directory, let's go ahead and go back into documents where we're supposed to be. Okay. And we can go ahead and run that same command to get it uploaded in the right spot. All right, great. And we can double check and make sure it's there. And sure enough, our My Shell file is there. Now, to execute that, it's pretty simple in PowerShell. You simply just call the file. And you'll notice nothing really happens. It just kind of hangs there on this side, right? And so if we go back and look at our Netcat tab, you'll notice that it's listening on this port and that we had our compromised victim connect into us on this side. We're not really seeing anything happen on this. What it does let us do on this side, we could type in, "Who am I?" and it would tell us who we are. And you'll notice that we are in a PowerShell. So what does this mean? This means that that remote system is automatically connecting back to our Kali Linux box. And in this case, we are automatically logged in as operator 2. So every time that shell script runs, it's going to immediately open up a connection back to us on the Kali Linux. We don't have to use EvilWinRM or anything else at this point. Yeah, I agree with you, Gordon. A desktop can be messy. You may never notice, right? All right. So one thing that we would do as a hacker is, add this to our startup applications on the system. That way, if, they rebooted or something else, it would automatically try to connect back to this Kali Linux machine. Obviously, it's trying to connect back to a local IP, .5, but there's nothing keeping you from sending this over across the internet back to, some server on Amazon that you would have it connect, and then you could do a shell to pull it from there back to the house or whatever you're trying to do your attack from. So we want to try to set up some kind of persistent connection back to this corporate workstation. And so to do that, we're going to use a command and control network. And this is usually what you see hackers do so that everything phones home back to them. And you can see this with DNS. You can see all sorts of stuff. We're going to use one that's called Empire. And so Empire allows us to always have that remote connection to a system. So we'll create a new tab. We're going to rename this one Empire, I'm sorry. And we're going to set up this server that would always be listening. Again, something you would do, not probably at your home, but you would fire up a ephemeral Amazon shell or Amazon container or VM, and then you would have Empire server running on it so that people would try to set up their connections going back to it. And because you do this based off DNS instead of IP addressing, then you can have your DNS change out to different IPs. So once somebody figures out you're doing this on an Amazon VM, it gets taken down. You fire up a new one, DNS reroutes it to that one, and you keep going. So in this Evil Empire, we're going to go ahead and launch that up, and we're going to use PowerShell's Evil Empire. I'm sorry, just Empire. Keep computing that up with WinRM. And we set up our server. So this is going to load up. Again, this is a listening system for people to remote connect back into us. All right, looks like everything's up and running. We'll notice down there at the bottom that we currently have 0 agents and 0 listeners. So we have to set up agents for this thing to listen to and ways for them to connect back to us. And so we're going to go ahead and open up yet another tab. And we're going to rename this one our Empire client. And in here, we're going to fire up the client. And this is what you would do on this side so that you could connect into those systems. So we load up PowerShell Empire client. And we're loaded up, ready to go. All right, so we connected back to our server that's running locally on the same system. And like I said, we need to set up a listener so that the agents have something to send that information back to. So we're going to set it up, and it uses a similar structure as Metasploit in terms of the way that you set things up. So we're going to say use listener, and we're going to do a simple HTTP listen. All right. And then if we pull that up here, use, not user. There we go. Okay. And so it tells us all the defaults on setting up this listener. And the whole idea here is that we just open up an HTTP or HTTPS listener with either PowerShell or Python, and it uses simple GET post for us to collect information back from people. That prompt is to kind of help you know where the program you'll be. You'll notice this listener prompt change down here. So we need to set those particular modules. In this case, we would click on something like options or type options, and that gives us, again, all the options that we can set inside of there. In that table, one of the fields that's required is port. You can see that's set for true, and that's one of the required sets. And right now it's set to empty. So we got to tell it what port we want to listen on. So because we're using the HTTP listener, we're going to go ahead and set our port to 443. And we'll go ahead and execute. All right. And so this listener is up and running on our Empire server. And then what we want to do is when they go to this particular website, we want them to do something on their side. So we're going to set up a reverse shell so that it implements in that kind of like that PowerShell script that we just talked about. In this case, we want to set this up. So this is really a phishing attempt. If you guys are paying attention here, we're really kind of setting up a fake website. We're hoping to get the user to go to said website, and it will immediately create a remote shell on their system without them noticing what's going on. So we're going to go out here to use Stager. Multi-launcher HTTP. Okay. And with this Stager, we can see the different options here, and one of them is going to be a listener. And so we need to set the listener that we just created before, this HTTP one, and associate it with this multi-launcher. Now, multi-launcher is really just this really cool terminal shell. It gives us much more power than just a simple PowerShell shell. So we're going to say use that HTTP listener. So use listener HTTP. Okay, great. And then we're going to type generate. What that's going to do is generate the shell code that we need them to execute. What did I miss here? Go back to my options. Listener didn't get set. I must not have used that correct. So let's try that again. Set. I used use. I need to say set. Set listener. There we go. That's better. Options. I can confirm, make sure my listener is now set to HTTP. Great. And then I can use execute. And so what that does is give me a PowerShell command that I can use on a far side to get that system to go ahead and execute what's going on there. You got stuck on, let's see, 15. It pasted correctly, but when I press enter, nothing happened. Not sure if I can control C. Let's see. Are you following along with I am just a little bit further ahead? Is that what I'm seeing, Yuritsa? Is that right? Okay. Yeah, I'll tell you when I get there because I'm trying to remember exactly. It's been a little bit there, but I believe in some of these cases you won't see traffic, and so that's what I want to make sure before I tell you that. Right now, this is just dumping it out to the screen. Alternatively, we could have used this out file, and that would have just generated a file for us, but that's okay. We're just going to use the copy and paste method here. Thankfully, this is automatically copied to our clipboard when we run this. So you can see that down here, stager copied to the clipboard. And so all we need to do now is go into our EvilWinRM, which is again our connection back to that remote machine. We're going to go ahead and close the shell because it was just running that script, right? We were giving you an example of how to set up a remote connection script, but we want something far more advanced than just a simple netcat connection. So over here, we're going to call EvilWinRM. All right, this is our little desktop, and we're going to set back up that same connection, connecting in with operator 2. Great, we're back in there. And so we're going to use this PowerShell to create a new batch file that we're going to end up going ahead there. So we're going to go new item, my launcher.bat, and looks like I misspelled that, so let's delete that. And try that again. There we go. All right. So we've got this little file here. It's an empty file, but we're going to end up copying and pasting material into that. And to do that, because we can't really, use a UI on this, we're on a remote system, right? So we got to have a command line way of doing that. And in PowerShell, it gives us an option to do that. We use the set content command. And so we will go set our content for my launcher. And then inside these quotes, we're going to go ahead and copy and paste in that little launcher that we created. And hit enter. And then we'll notice if we look over here, we now have our little launcher bat file that we created. And so if we call that, oops, I hit the wrong button there. Got to reconnect in. There we go. And we can use my launcher.bat. And so when this runs, you'll see it execute that little PowerShell command that we did here. And if we go back to our Evil Empire client side, you'll see that a new agent has connected into us. And we can see our agent's up there, it's listening, and we have an unread message over here on this side. So that system has now connected back to our head end, up to our server, this one here. And we can see that it's connected in here on our server. And then our client, our way to interact with our little Evil Empire section here, is checking in. And so we need to be able to see what messages are in there. And so if we go to agents, we can see that we have this nice PowerShell connection coming back to us. What's really important is this name over here on the left. So we will highlight that name. And we can go ahead and copy this because we'll need that here in a second. And so if we want to interact with that agent, we use interact and then paste in whatever that name was, like that, and hit enter. And now that we're on that particular agent, we can do info, and we can see all the information it has collected from that particular FAR system. So it gives us quite a bit of good information. We know that it's an AMD platform, its host name. We can see when the last time it was up on this side here. We can see that its profile and how it was able to get to us, that kind of stuff. So it worked pretty slick, pretty easy there. Once we have a way of doing that, we want to get way more information about that remote system that's communicated back to us. And so what we're going to do is use a module called Seatbelt, and Seatbelt's used in pen testing for enumeration. And it's purely meant for us to pull information out of a Windows system. And that way we could use that to kind of figure out how we're going to do an attack all the way through here. So much like Metasploit, we're going to use particular modules. So we have use module, and we're going to be using a PowerShell, situational awareness, host, and seatbelt. All right. And we'll notice with seatbelt here, no, you're good, man. I'm all for it. You'll see here that we can pull some additional information inside of here, including commands, computer names, full names, etc., including passwords, usernames, and passwords that we can pull out of there. So we need to set a few things up in order to make that work. So let's go back here. And we can see that by default, we have our agent in there and everything else. Excuse me. So we're just going to execute it with no extra options at this point. And that task is running in the background. So we'll just wait a little bit here. It's going to retrieve information out from that Windows box. And if all goes well, we should be able to get a dump out here on our screen. I'll mind you that seatbelt is a real simple C project. It performs a bunch of security-oriented safety checks, relevant for both offensive and defensive perspectives. It's actually a very scary tool. It's part of the MITRE framework, and it dumps a lot of information back about a Windows system, way more than you would want anybody to have access to that was trying to break in, that's for sure. So it takes a little bit for it to come up here. Let's see, on the server side, we still got that task out there running, so that's no big deal. Should be popping up anytime here. Usually takes about 2 minutes to kind of go through there, sometimes up to 3 minutes for it to execute all this information that it's pulling. It's going to try to do the best it can with the information it has. And right now, again, we didn't supply any username or password or anything else. We just told it to run against it, and let's see what we can pull back. Have any of you worked with Mimikatz? I know I'm throwing out all these weird technical jargon apps, right? So Mimikatz is a pretty popular one on the Windows side for you being able to dump the password hash files. It allows you to do a lot of stuff in the registry and do some tweaks in there. So I encourage you to kind of play a little bit with that as well as the other ones. There again, this is a great opportunity in these ethical hacking labs. There's labs that match up specifically with this stuff, right? So you're going to have labs that talk about Nmap and HPing and network analysis, doing stuff with Hashcat and Metasploit, and being able to use backdoors with Netcats and that kind of stuff. So you can definitely get in there. This link would be the ones that are available from NDG. And again, that one is for their NetLab Plus side. Everybody here is going to get access to these labs here today off my Fort Hays side, and I'll let you have them here for the next couple weeks before school starts if you guys want to go in there and play with them. As instructors or administrators and such, NDG is really good about giving you guys access to play with these labs. That way, if you decide to use them in the classroom, you're welcome to do so. Mimikatz is a little different. It is spelled like that. Okay, so we come back here to our client and we see a bunch of stuff got spit out on the screen up here, and we're going to end up scrolling back a little bit, kind of see what kind of information we got. And you'll notice we got tons of information that it was able to pull. Again, this is with no real connection other than we are on that operator account, and we just ran basically a way to try to dump the database, see what's all in there, that kind of stuff. So let's scroll back up here to the beginning. There we go. And so we got some good information out of Seatbelt. So if we kind of scroll through here, we can see all the internet interfaces it's associated with. It basically dumped the ARP table, the route table, all the auto runs that happen on startup. So we can also say, hey, this system always runs VM tools and it looks like Java scheduler, which is great because then again, as a hacker, we can say, okay, well, if I just replace Java update with my own app, they're not going to notice the difference because it's always in their startup already. What we're eventually looking through here is we want to look through some credentials, nothing there. We look through their DIR and it kind of just goes through the different ones. Now, this is kind of helpful because we can tell on this system, there is an administrator account, there's the operator 2, and then that's kind of it. So those are the only 2 people that have ever logged into this system or have accounts rather. Notice that operator 1 and operator 3 are not really part of this particular workstation. We can also see that the administrator is obviously there, which we should know because that operator or that administrator rather, we know that they left open some tickets and our remote access way in from before, right? So we'll keep scrolling through here. And one of the stuff that's really interesting to us is in the local groups. Make sure I didn't pass it here. There we go. So we got some file information. It's actually kind of hard to weed through the amount of information you get back out of here, that's for sure. We can see what's all installed on this computer, so it gives us a dump of all the different apps that are installed. There again, makes it awesome as a hacker. We can figure out what versions they're on, is there vulnerabilities that we can use to attack. It's pretty scary what all gets dumped out of there. All right, what we're really looking for is this local group section, right? And what this local groups will tell us is all the users, again, that are operating on this system. And we can see that we have our corporate work administrator and we have a NetLab operator 1. Does anybody know what that kind of tells us about operator 1 and administrator? Oh, if you were talking, JB, I think we lost your audio back to a low pitch again. Yep, we lost your microphone again to kind of a really low pitch. So in this case, what that kind of tells us is a little bit like when Michael said his privileged accounts, that corp work administrator tells us that that is a local administrator account, right? Because if it was a NetLab / administrator account, we know that the work group that we're dealing with is NetLab. So we know that operator 1 is coming from Active Directory, where that administrator account is just local to this machine. Does everybody kind of see what I mean there? You got it. So the local admin account may have administrator rights, but that operator 1 account, because it comes from Active Directory, more than likely doesn't necessarily have admin rights on this particular host. It could, but it doesn't necessarily have those. If we look through the rest of these, we do see there's other accounts out here. We have corporate work guest that's out here. It looks like at one point, remote desktop SCADA seemed to connect in there. And so it's interesting on what they're using this corporate workstation for. We're going to try to glean some more information from the system as we move through it. But it did collect quite a bit of information that's useful for us. If you remember, you connected as operator 2, right? And so you don't have administrative access on the system. We need to figure out a way to do privilege escalation so that you can gain more information about this host. And in this case, operator 1, if we scroll up there, like somebody said before, that they have admin rights, right? Because they're under the admin portion of that. So operator 1 was made a local administrator on this workstation at some point, probably during the trouble ticket, and it was never really removed. And you see this, right? Sometimes people give local admin rights because they're tired of getting phone calls. The operator's just trying to install software on the machine. They're not really doing anything malicious, but they forgot to take away their local admin rights. So you're absolutely right when you mentioned that before there. They're not necessarily the same person, but they do have those privileges in there. So what we want to do is try to escalate off operator 1 so that we can get some privilege escalation. We want local administrative access to this system. So we're going to come over to our corporate workstation. Right. And in order to gain access to this system, what we want to do is kind of log in to this system because this would be its daily activity, right? In other words, we're trying to create some activity on this this workstation. We don't want to, we're not really hacking or doing anything at this point. So put your hacker hat off. We are operator one logging in for the first day. We're the administrator helping through a ticket, that kind of stuff. So as we come into this workstation, we want to go ahead and log in as the operator. And the operator logs in, they do some things for the day, and they decide to go ahead and log out. And then at that point, the domain administrator comes in at some point and they're trying to figure out what's going on, what's wrong with the system. So the lab DA is logging in and they have a little bit better security password of training, the $. And they're going about their business and doing their thing. In the meantime, back here on the Kali box, we'll notice that, local administrator one had privileges, right? We saw that when we were up here playing with this box here. And it would help if we reconnected to that operator machine, at least as operator one, so that we at least had local domain privileges, which is great. So we're going to go ahead and scroll back down here to the bottom of the Evil RM1, and we're going to hit Control C. We're going to cancel our connection coming back from operator two. And we're going to recreate our connection to that system using operator one this time, because we already know that password from a previous lab. And we're going to go ahead and create that same launcher batch file into this user because they have administrative privileges. So new item. There's our little batch file. And we're going to go ahead and set our content here. This should still be in our clipboard, which in my case it wasn't because I copied it out and pasted it in a different one. So I'm going to steal it because it just so happens to be upside here. There we go. And then now as operator one, we're going to run that batch file in the background. Again, this is something we would typically set up to start on boot for that particular user so that when the computer boots up, it automatically runs this as a backdoor. All right. We go back to our client. Scroll back down here to the bottom. And we'll see that a new agent has checked in this case. And that's because now we have a different operator logged in. So if we look at our agents, we can see that the same system has come in, but now we have this operator one that's come in on this side, right? And so we want to interact with that agent. I should pause here. I'm getting closer. Who was that had trouble earlier yet? Yuritsa, were you able to figure that out?
So I have to restart some of the steps. So I stop so I can pay attention to what you're doing.
Oh, I'm sorry. I should have checked in with you sooner. I was just noticing I was coming up on step 15 here, so I wanted to see if I was in your area.
No, the problem was that I didn't put the quotation marks. That's why it got stuck there.
Gotcha. All right, so if I actually hit tab here, it's going to autocomplete because it sees this as the active one. That's why it's green on this side. So I can tap complete. And now we're connected out to that new agent. And we're going to use Mimikatz. This is what I was talking about before. Again, it's another module in here. Mimikatz, you could run this local on Windows machines and such. And it's really good at basically dumping all the credentials, any tickets, anything on that system that we would be of interest so that we could steal credentials and go break hashes, that kind of stuff. So we're going to use that module that's baked here into the Evil Empire, or the rather Empire. I don't know why I get stuck on the Evil Empire. There we go. So we're going to use the module, PowerShell, credentials, Mimikatz, and we're going to just do a simple command shell of that. And again, Mimikatz is just, this is PowerShell's version of using that. If you go look up Mimikatz, you can figure out all sorts of techniques on how to do that as part of the MITRE ATT&CK framework. So this looks good. We just got to tell it what command we want to end up using there. So we're going to set our command to say use the sec URL SA logon passwords. And what this does is it goes through and finds the all the systems that have logged into this or logged in recently to this host and tries to see if we can't dump their credentials. If it can't dump their credentials, maybe they have some Active Directory tickets out there, the same things that we compromised in the past there. So if we go ahead and execute that, and we'll let that task run, and it does take a little bit for those up there. This one can take a little bit longer because what it's doing is trying to sort through the entire registry, see who logged in recently. If it matches, can they get the information about them, that kind of stuff. So this one can take a little bit. We can see that job started out here. That's great. So I know this part is getting super technical on this side, and I apologize for those of you that aren't familiar with these tools or haven't had a chance to play with these. The good news is again, I'm going to get you access to something like this, which is those ethical hacking ones. And so the goal for this portion of the lab set is somebody that is familiar with ethical hacking and done a little bit of those type of traits so they know what they're attacking. Now they're trying to learn a little bit about the OT side. And so that's really what these last 7 labs are all about. All right, so we scroll back up in this output, scroll back up here to the top. There we go. And there's a couple of cool things that we can see here. One, we can see that, operator 1 logged in at some point. We can also see that the lab DA user logged in at some point. And we can see these different authentication tricks. There's operator 1. We've got some Windows Manager stuff that's really just baked into Windows side of the house. But it did capture a bunch of different credentials, so to speak, in here, right? And what's nice is instead of us having to kind of sort through that, it's already here. All we have to do is type credentials, and Mimikatz will dump those. And we can see 2 different hashes. We can see one for the lab DA account, and we can see one out there for the standard corporate work machine that was in there. So this is great. This gives us a little bit way of doing a hash of this, but the problem with this is we really don't know what this hash is at this point, right? So we don't have a password, but we do have their hash of the way they logged in there. In the previous lab, you guys remember using Hashcat to kind of determine the password. However, in that lab, you use that RockU login to do that. And it turns out that this hash for this lab DA is not really in that file. And so you would have to end up doing some kind of brute force attack. And while there's some capable systems out there that can run over 190 million hashes per second, this particular password is 9 characters long, and it's going to take a long time for us to brute force that password. Scarily enough, we don't need the password in order to break in the system. We just need that hash. So Evil NRM can use that hash to log in without ever having to crack the password. And it does that through a technique called pass the hash. So what we want to do is highlight this user, LabDA. We're going to end up stealing this little piece of hash here. And we'll go ahead and copy that selection. And if we go back to our WinEvilRM, we're going to go ahead and log out of our operator 1. And again, what we're going to do now is use this pass the hash technique that EvilWinRM has and allow us to log in as that lab domain administrator without ever knowing the password. So if we do an EvilWinRM -I and we connect into that local desktop on a -U, we want to use lab.da. And instead of using -P with a password, we're going to use -H as a hash. Pass that hash in there. Enter. And scarily enough, we are now logged into that remote system as the LabDA. So we've successfully found a way into this corporate workstation. And we found a way to get privilege escalation all the way up to the lab domain administrator. It's pretty cool. It's kind of a fun little lab. Students that have played with this or done some hacking and stuff like that, this is all pretty real, right? You've got a way into the system. You did it through phishing or whatever else. And once you gain access to that system, as somebody's always said, once you're in, you can start going, right? And in this case, they just sniffed around enough to figure out who the different accounts were. Once we figured out who the accounts were, we used some tools to figure out who's actually an administrator on the system, and use some tools to dump the password hashes of everything. While we can't crack that password, we can use EvilWinRM, which has the ability for us to pass the hash and log in as if we already know the password. So, pretty cool little system. So honestly, how many of you did I lose at this point? And it's okay if I lost you. That's okay.
The brain hurts, but it was okay. If you had to summarize this in 1 or 2 sentences, what we just did, I get the idea of the command control thing. That evil worm is some sort of tool using the Windows remote stuff to do stuff. But if you had to summarize this, what did we just do?
Yeah, I totally get it. That's why I said, am I losing people? Because it's okay.
I think
if we look at this topology, what we did was we are currently on this local system, right? And that's one way of doing it. But just know that this can be done if Kali Linux is out here on the internet. It doesn't matter. What we did was in an earlier lab, we were able to get in through the corporate workstation through some form, phishing, whatever else. And once we were able to get in, we dropped in a remote terminal shell. Now we're setting up command and control network. That just allows us to go from this corporate workstation up to our Evil Empire server, so to speak. And it's going to be a persistent connection. It's constantly coming back and talking to us. Once we gained access to this system, we did a lot of idea of reconnaissance. So at this point, we haven't done anything that would really be detectable on any of the systems. We're just doing recon as hackers. And during that recon process, we found out that that operator 1 is a local administrator on this system. And that the lab domain administrator had logged in at some point. You know, we did that in the lab. That's normal, right? People are going to log into the systems, etc. And it keeps that in the database of when they logged in. It doesn't store their password. It still has a hash. But what's nice is because that hash is there, Mimikatz is going to dump that out. And so EvilWinRM has the ability for us just to take that password hash. We don't even have to break it and get us in with that hash. And so at this point, we are all the way to this corporate workstation with a domain administrator account, which is pretty awesome. That was not 2 sentences, but I tried my best.
That was perfect. That was perfect.
Okay. So yeah, lots of moving parts there, lots of cool tools. Do I have all those tools memorized? No, sir. There was a time where I was really good in Metasploit, but that was back when it was called Backtrack again. So I am way behind the curveball of where my skills were back at that point in time. There's like things like EvilWinRM and all these cool tools now, like those didn't exist. There was barely scripts for a lot of this stuff. And now you have like the advent of AI and being able to bake that into some of these tools, it's pretty scary. As a matter of fact, there's a AI LLM that I'm having one of my students pull, and we're going to set up this fall. It's trained specifically with all the tools of Kali Linux. So it's basically a tutor for a student to ask questions about how to use a tool on Kali Linux. It's pretty awesome where they're going with some of that. Everybody now is a script kiddie, right? We just pull a script, change a few things, and away we roll. In the old days, we had to do a lot of work to get to do some of that. And I'm by no means a expansive hacker, I can tell you that. Thankfully, like when I was writing this lab or kind of building these out, I had heard about some of these tools and got to go play with them a little bit. That book that I mentioned talked about some of these tools. And so I kind of read up on them and tried to figure out how we could set up an environment that's somewhat realistic and still have that. Now, yes, we still have passwords like password 123, but no different in that RockU password list, right? There's 14 million passwords in there. So we could gather them in that way. And even better, as you guys know, instead of breaking, what's the easiest way to get a password from people today? Do we have to break passwords anymore? Yeah, you got it, Terry. Social engineering. Yeah, we just asked for it. Wait, what's your password? And unfortunately, that is way easier as a hacker than it is to go through this process of trying to hack passwords and everything else. It's sad. It's sad and it's scary, but it's job security, I guess. So. All right, let me pull this up here, make sure I'm on time. I believe our break is at 3, so don't let me overstep that one. All right, so we are in the corporate environment. We've set up some command and control stuff so we know how to get that attack back, and we now have a password hash for the lab domain administrator that we can use to log in to that system. So our goal now is we want to kind of work our way through the corporate environment to see if we can't find a way down into the OT environment, right? We're still over on the corporate side. We got to figure out if there's a way to get us down into the SCADA side, down and try to attack that little PLC controller. We should be able to get through these last 2 labs here. They are long labs, but I do want some time at the end of today to really understand what you guys are wanting to do for the capture the flag side. And I know a lot of you haven't done capture the flags, and so you don't know what to ask or what you want to do. Excuse me, but I just need some ideas so I can prep a little more for tomorrow on top of what I had already planned, because I really want to make sure that those that are heavily interested in the capture the flag side, that we cover everything you're looking for. Excuse me just a sec. I'm going to grab another drink here out of my fridge. All right. So you'll notice our topology grew a little bit, right? So again, this is usually a common layered system in an OT environment. You have the layer 5 where your enterprise stuff is at. You have some site business systems, and then you have the operations and control layer. And that's really where like your engineering workstations are. That's where most people would log in to get to their dashboards, etc. And being able to kind of pull that stuff out. So, yep, I hear you, Tom. And that's honestly the CTF stuff that we're going to be going through is the same way of us building labs. So if you want to build some custom labs or expand these labs, it's the same idea, same concept on the CTF side. Well, the way I like to treat CTFs is not necessarily, full blown capture the flag stuff. But it's more of I use them as skills based assessments. So it's a way for you as an instructor to give a test that the students really don't have the answers to, right? There's no way for them to cheat, and that you got it. So that's really what I try to use the concept of CTF for. The cool part is students react to CTF because it's game based, right? And we talked about that several times in here, that it's a game for them. They're more challenged. They really want to do it because they want to win, where nobody wants to take a test. So I get it. I agree with you. I'm not a huge fan of multiple choice finals. So what I tend to do on these CTFs is I tend to build out a Jeopardy section, and we'll talk about this tomorrow. And that helps them build up a little bit of points, and then they can start in on the hacking of the infrastructure and that kind of stuff to go capture other flags. When they get stuck, they can use some of those points to help them get hints as they move through there. So. All right. Well, let's take a look at these last two labs. And so this lab is called setting up the pivot, or setting up a pivot. And the idea is that we are still here on this corporate workstation. We need to find a way to get down to this the engineer's workstation down below here. All right, so this is kind of our pivot that we're looking through. We're trying to work our way through the firewall and get down into this engineer's workstation. So we've gained information about the corporate network. We're going to try to see if we can't use this remote desktop to gain access. And then we're going to set up a static tunnel in order for us to maintain that access through the pivot. All right. I'll break this off on another screen. And we'll stand back up our Kali box while we're getting that up. Yeah, and that's really my deal too, Terry, is I like that I like performance-based exams, and that's usually how I try to carry it out, because as you know, cheating is just rampant. If it's question-based, they can use their AI, and I don't get me wrong, I encourage AI stuff, but it's just too easy for them to go to an employer and then we're putting our name on the line saying they came through here, right? Or when an employer asks me, how good is this student, if they got quote good grades, but they can't log into Windows, then we have some pretty bad issues. So I really try to work on the performance-based exams. I used to write these really heavily, and then I got a little lazy. And so now I'm trying to go back and really get back into building out these performance-based exams. All right, so what we want to do here is, again, turn off the networks that we shouldn't have access to. We want to be out there on that corporate network. And we're going to do a little bit of sniffing around again to see what we can see on this corporate network. So we're going to bring back out our friend, the Nmap tool. And let's look a little bit about what this command is trying to do. So if you remember, 2.2 in our topology was this domain controller, and we haven't really touched it yet. So we're kind of going back. We've exploited as far as we could on this corporate workstation. We've got all the different user accounts and whatnot. And so now we're trying to get into this domain controller to see if there's a way to get further down into these systems. No, the reason this is this way is Active Directory, right? So we're letting all these operators connect up here on the corporate network using Active Directory. But because we're trying to use LDAP or Active Directory for access control down on these lower systems, that gives us 1 point of failure, and that is the Active Directory setup. So if we look over here in our Kali box, apologize for bouncing around again. And on this Nmap, we're going to go ahead and run a scan on the domain controller. And our goal here is to simply see what ports are up and going. It's non-standard ports, higher end ports. Is there something that we can try to compromise on this system? There's quite a slew of open ports. Does anything on these ports here, does any of those kind of stand out to you a little bit? Besides what it specifically says in the lab. So we talked a little bit about remote desktop. Does anybody know the port number for remote desktop?
3389.
3389. Memorize it. Might be on a quiz, right? So just trying to backtrack. Does anybody remember the port number for Modbus? .502. Good job, Carl. So those port numbers you might want to know. Hint, hint, wink, wink at the end of the week here. So remote desktop is 3389, and so that allows us to use remote access into those systems. 53 is our DNS, so we're running a DNS on this, which is pretty common when you have an Active Directory set up. It obviously has LDAP running for the Active Directory. We can see a Kerberos server, all pretty common for what we would see running on an Active Directory type setup. Nothing out of place. It's pretty much the de facto standard setup there. So next we're going to end up utilizing Nmap, and we'll kind of run it on the corporate workstation, see if there's anything that we missed that may be of use to us. So we're going to run that same scan back here on the corporate workstation. And so we'll notice as it's trying to go through the OS detection side of the house that we also have some ports open here, but we're noticing this reoccurring theme. And in this case, we also see that our corporate workstation has 3389 as well. So there was some remote desktop turn on these, more than likely because the administrator, network administrator, or the domain administrator wants to have remote desktop to support their clients. So they can go in and fix any issues or bugs. It's a pretty common thing. We do see port 22. Does anybody know what 22 is? SSH, yep. So SSH is running on this corporate workstation, which is that normal? Would we normally see SSH running on a Windows box?
We do not.
Yeah, that's pretty rare. We shouldn't really see that up there. It's not, hugely common. Normally you're going to see stuff like 3389. On a Linux box, yeah, you could see 22 happen all the time, right? However, it is used for remote access, and in a corporate world, you may use it for doing, routers, switches, firewalls, etc., because it is accessible over Telnet versus, insecure Telnet. And it's really commonly used with SCADA and PLC equipment as well. But we typically don't see it as a server running over here. Okay. And then last but not least, let's go ahead and do Nmap again, only this time we're going to scan our firewall and see what we can find out there on the firewall. you'll notice our firewall is starting to drop some packets there. And this is pretty common. So it's trying to prevent some scan attacks and things like that. It's trying to delay it out a little bit so we don't have some issues. But we really don't end up seeing a whole lot of ports here, right? We see port 80, which we already knew about that one from some scans we had done prior. You may end up seeing port 53 show up here. And that -0 right now is really what's taking the longest because it's trying to identify the operating system and whatnot. And we'll also end up seeing 443 open. And so it turns out with this particular system, it's using pfSense. And so if we actually go out to that URL, we'll notice that it's redirecting our 80 traffic to the 443 site, right? And this is pretty common with firewalls. They want you to use the secure login. So if I click on the advanced side and accept the risk, we can see that they're running a pfSense on this site, right? This command, again, is going to take a little bit for it to actually run. It's okay. We've got the basic information we need. At the end of the day, what this information really told us is it seems like the network admin likes to use 3389 for remote terminal access so that he can bounce around the network and not have to be physically at these. But we also know there's the caveat with 3389, and if we log into that, it's a good chance that we can get caught that way. So we want to be very careful as to how we go about using it. All right. It's pretty risky as a hacker, but if someone was already connected with the given credentials, we'll end up bumping their connection off, which could raise a flag. In this environment, we want to see if the corporate workstation ends up having access to any other networks, computers, users, etc. And so on Kali, we can use what's called X-Free RDP, and that allows us to connect into a domain controller or into a RDP type session. And the corporate workstation is one thing that we might connect into, but we could also reflect straight into the domain controller. It's not as often that we would hit the domain controller with RDP. So the chances of bumping somebody out is less than you would on somebody that's on a desktop all day long. That's pretty chancy there. So what we're going to do is, for the sake of this lab, is we're going to jump into that corporate workstation. So this may be, at midnight when we wouldn't expect anybody to be on, and it would lower our chances of getting caught as a hacker. So we're going to use X-Free RDP. And again, this is just a remote desktop client that's baked into Kali. We're going to try to log in with our Operator 1 account because we know that is a local administrator. And our connection is going out to that corporate work machine. All right, and it's using a little 509 certificate, which is pretty common when they're using these to connect. So we'll go ahead and hit yes. All right, is everybody back? Well, I crashed. All right, so with the recording going, as you can see, we were able to...
Not seeing your screen.
Ah, thank you. I knew there would be something else missing.
I figured this is a new kind of training. Zen, you have to know what's going on.
Yeah.
There we go.
Awesome. Thanks for that. I appreciate that. Okay, so RDP worked, and we were able to reflect into that corporate workstation on here. And we can see our normal desktop, everything else. If we click on Start, we can see this remote desktop connection here. And if we click on that, we're going to see that, it's already connected to 2.1. Well, that's odd, right? 2.1 was our what? Does anybody remember what 2.1 was? Yeah, it was our pfSense, right? Why in the world would it be remote desktoped into our firewall? That's odd. Okay. And if we go back to our firewall, from what we did earlier, there was no 3389 open on our firewall. There was just 80 and 443 and standard DNS. So that's a little bit odd. But okay, we'll work with that. Something seems to be going on there. Does anybody have an idea of what might be going on? Most of you are networkers. What could they be doing here for doing remote desktop to a firewall? I'm sure you're telling us the right answer, JB, but your volume there, the mic's not picking anything up anymore. It's not even low. We're just not getting any audio. Firewall with a Win SDKN. Yeah, you got it. You nailed it. I figured you had the answer, JB. It's you got it. We're redirecting. More than likely, we're hitting some kind of ports on the firewall that is doing port forwarding off to something else, right? And you guys do this at your home or something like that. You open up ports out to the internet, but it really just kind of reflects into something on your inside. It's pretty simple NAT reflection or just a port forwarding going on. And we would do that because we don't want our corporate network to have access to our SCADA network or our PLC network, et cetera, right? There should not be connections or the ability for traffic from our corporate network to go down into something else, right? How did I notice it was a redirect? It's just odd. You wouldn't normally do an RDP session directly to a firewall, right? Because this IP address is the firewall. So it's a little odd. Doesn't necessarily mean that's the case. It's just a little odd as to what's going on. And we'll notice that the operator 1 was the last person to log in on this side here too. All right. So we're going to try to explore this a little bit. Let's go ahead and just try to connect. Maybe we get lucky and the password's in there, right? Well, we actually know the password. So for operator 1, right, we already did that back in the day. So let's see if we get a connection. And we didn't get one. So let's try this again. It should have pulled through. Unless I missed a step back here. Yep, looks like the RDP came through. Why? Yeah, we should be good. All right, let's try to close it out. Let's try this again. We did get a cert mismatch. We got this one up here, and that's for that connection to that machine. We should be able to connect out here. Yeah, I hear you. So unless this firewall is broken in this lab environment, but the idea is that we should be able to connect out here. For some reason, we can't. So let's go back to my topology. pfSense is there, but we can't get to it, which is common. Let's see here. Sure, I'm not missing anything on this side. Be my luck the lab environment is broken or we did something to break it while we did the transition. Let's see. Oh, we can see our firewall. Interesting. Our corporate machine is not able to log in there. Huh. Check myself here. Yep, firewall's up and we're good. Yeah, I'm not sure. I don't, it should work exactly like you see there, Carl. I'm not sure why it's not. Um, all right. Yeah, it should. It should pop up with a password prompt there if everything's connecting out. So, tell you what, I'm going to end this reservation. I'll come back, see if maybe I just messed something up. There's nothing that we done so far that would that's not easy enough to recreate. So. Yeah, everything on those VMs is internal. There should be no internet connection on those. It's almost like that pfSense didn't get turned on correctly. So I'll restart this lab environment and double check. Okay, cool. There's a chance I just typed something wrong or I hit something wrong. So entirely possible. Yeah. Yeah, we had to change the background color. So if you're familiar with the NetLab product, you don't really want a gradient by any means. It hurts performance overall. So they set different color backgrounds to make that work. All right, so we go to this Kali box. Let's get that pulled up here. That's why you see a solid red on Kali. And so we'll ignore all those nmap commands because we already know that knowledge. I'm just going to jump straight into the RDP. And before I do that, I do have to shut off my other bad networks. I'm trying to remember which one that was. There we go. 3 and 2 should be good there. Might have got the wrong ones. 2.5. Oh, those systems aren't quite booted up yet. That's what's going on. There's a delay here, and it tells you that in the lab if you follow directions, Jason. You got to get the server up and booted before you have your clients log in. So it's entirely normal. Let's see here. Do you focus on subnetting training in your programs, recognizing? Yeah, so our old school instructors on the Cisco side of the house do still focus on the subnetting and making them understand what it is. Typically happens in our CCNA 1 and 2 course is where they cover most of that subnetting side. It's not that they necessarily need to memorize it anymore. A lot of students ask me that is, do I need to memorize this? Nah, nobody does anymore. But it does help with your, like when you're out in the field and such, you can recognize what that is. You may not remember or memorize them all like you used to, especially as you start to gain more knowledge, but everybody has a cheat sheet, right? Yeah, they should definitely have the background of it. Yeah, and now you have ChatGPT. Yeah, you're right. AIs that really make a change. That in the back days, you could just Google a subnet calculator and it would give you everything you needed on that site, right? All right, so let's see if my RDP works. There we go. And I'm going to use a capital Y. I might have actually typed that wrong last time. Shouldn't have had an effect on being inside this machine. We'll find out here shortly. There we go. That's what I would expect. Hopefully. And yeah, we should get this prompt up there. So I'm not sure what happened before. That was just a fluke on that side. But we should be getting this prompt, and this will allow us to type in the password we already know. And in this case, we should get this little security warning. We'll go ahead and hit yes. Yeah, you got it. X-Free RDP is just remote desktop. Exactly. It's just a Linux-based tool is all. Okay, so we got access into some system. So we're going to go into the command prompt and try to figure out exactly what system we got into, because we know we didn't get into the firewall. The firewall is not Windows. And we know we were able to get in with this operator 1. So if we do a little bit of host name here, we found our ing work. And so we don't know this topology as a hacker, but really what happened here was this operator was using a credential against the firewall, which redirects that RDP to this engineer's workstation. And this firewall loop should not be there. It was evidently set up at some point in time. Administrator forgot about it, whatever reason, but for some reason they left this connection out to the firewall so that it would reflect back to the engineer's workstation. Note, we didn't see it on Nmap scans. We didn't see a bunch of other stuff there. So it is a firewall rule that just happens to be left in the firewall. And our scan didn't tell us anything about it, right? We just happened to compromise this system, went in to check to see if there was the last time somebody connected off this. And in this case, they did. They used this RDP to reflect into the SCADA network. So let's do an IP config. And this tells us that we're on a completely different subnet, right? So now we're this 3.20 system for this engineer's workstation. And we also have a firewall at 3.1, okay? And so at some point, they created a port forward rule that allows them to access this on the operations control network. Not the wisest thing to leave around on the system. So that's interesting. And to avoid being detected from here on out, what we want to do is we're going to end up setting up an SSH tunnel. And so what that will allow us to do is do a SSH reflection through here so that we no longer have to take over the RDP side when we connect from our Kali Linux box. Instead of connecting to the engineer's workstation and then connecting from there, connecting from Kali to the corporate workstation. Then from the corporate workstation, we are doing a RDP session back into the engineer's workstation. We would like to be able to set up Kali to directly allow us to connect to this English workstation, right? And we can do that through some SSH tunnels and reflect that traffic going through here. So we're going to go ahead and kill our connection out here to the desktop. And we're going to also go ahead and kill our RDP session over here on this side as well. And so what we want to do is set up a pivot for us to pivot from the corporate workstation to that engineering workstation through RDP, but we don't want to get caught by directly RDPing to the corporate workstation. So to hide our tracks, what we're going to do is set up an encrypted SSH tunnel through the corporate workstation that will then connect onto the English workstation, or the engineer's workstation. So on Kali, we're going to set up this fancy SSH tunnel. So we're going to SSH 5555, and this is just a port number we're setting up on our Kali Linux box. 172.16.2.1. And this is on port 3389. Now, if you notice, this is us connecting to the firewall on that port and we're setting up a listening port here on our Kali Linux box. So we're taking the corporate workstation VM completely out of the loop at this point. And we're going to forward that traffic using operator 1 at 172.16.2.4, which is that corporate workstation, right? I'll try to connect out there, and it allows us to connect in, so we can do yes. And we know our operator's password, and we got that set up and working. Okay. So what does that really do? That really just sets up a local port on this Kali Linux box that we can connect to, and that sends us through a tunnel all the way through the corporate workstation on the way down. And this is pretty common. Administrators will use this as a way to kind of bounce and remotely connect to systems. It does hide some tracks and things like that, but it's a pretty cool little way of doing reflection through there. So to see what I'm talking about here, if we do a simple netstat-ant on this system, you'll notice that this Kali Linux is currently listening on the local host of 5555. So all we have to do now is use our RDP tool. And we're still going to log in with our operator account. And instead of this time connecting out to the corporate workstation, now what we're going to do is connect just to our local host on 5555. And if everything goes well, we hit our Y. And sure enough, we were able to reflect all the way into that SCADA system. So again, what we did was we set up an SSH tunnel from Kali to the firewall, and then reflected the traffic as if we're coming from this corporate workstation to go all the way into this engineer's workstation. So pretty cool little trick to get around it. And again, we can confirm that we are out here on that English workstation, or the engineer's workstation of Ingwork. So pretty cool little one there. We set up a static port in this case, 5555. You can also use what's called the dynamic tunnel, and that will allow you to avoid having to forward ports and do that kind of stuff directly. It's really cool if you use it with proxy chains. And so what that does is makes it easier to set up multiple ports. So if you need to reflect multiple ports going in, you can use proxy chains. If you get that book that I mentioned there, that book has you go through and use -D and proxy chains to set up a similar type of remote connection in there. All right. So our whole objective was to find a way into this engineer's workstation. Now we got to go in and see if we can't figure out a way to attack our PLC controller clear from out here on the outside world. And that sets up the deep pivot. All right. So I know we're late in the afternoon and we did some really deep stuff right there. Is everybody somewhat able to follow along with how we're making our way through this network, even if you don't understand the tools 100%? Okay, great. At least one thumbs up, 2 thumbs up. That's good. All right, glad to see it. Hopefully I didn't lose everybody as we got into some of these fancy tools here. Now, again, with these fancy tools and stuff, there's a lot of stuff that that we kind of took for granted there, right? Simple passwords, things like that. But there's no reason why this wouldn't happen in a real world. It's just a matter of taking a little bit longer to gather the information, that kind of stuff. Oh, sorry about that, Yaritza. I can definitely slow down. If I'm going fast, please tell me. I'm more than happy to slow down there. And yeah, if you don't have dual monitors, it definitely makes it tricky.
Yeah, it's the upgrade of this lab that's got me. They got new 27-inch monitors coming in here, and right now the machine's not set back up the way it should be.
Good. And your audio is way better than it was, so good.
Hey, at least you didn't get the question. I added a third monitor and I got the question about why, what are you going to do on the third monitor? And they for some reason, they think I'm doing something suspicious on the third monitor. I don't know what that means, but muggles.
No, I hear you. When I went from my work at home job and took the teaching job, I brought in all 6 of my normal setup that I had at my work at home job, and they thought I was crazy. And of course, it was my own, so they didn't really care. But when I took over the institute and stuff, I made sure to they upgraded my monitors that I was going to get my 3 at least. All right. So this is our now goal within this new lab. And this is kind of the keen culminating project. Our goal has been to get from Kali Linux. We're going to reflect through the firewall into the engineer's workstation. From that engineer's workstation, we're going to find a way to get to our SCADA VM and ultimately take over this PLC controller. All right. So we talked a little bit about proxy chains and all that kind of stuff. We're going to end up using that this time around. It's a little easier to configure and set up for us. And then we're going to use a full-on reverse shell to get clear down in for that deep pivot. All right. So to get started, we need to go ahead and fire up our SCADA environment at this point because we're ready to kind of take everything over. So just like we did in some of those early labs, we just have to fire up our PLC and our SCADA system, get us started. I can tell you the inner hacker in me, this is one of my favorite labs because at this point you've got to do all these cool tools to get credentials. Now we're actually getting to the grand finale where we get to mess with a very far off system. I don't want to say cause damage. I'm recorded here, so that's not my favorite thing. Just kidding. But you're able to compromise a far system and succeed in what we were trying to get after. All right.
I've got you recorded out, so if I ever need a favor.
Yeah, something like that. I'm just kidding. No, don't come get me. All right. So we're going to log into our editor. And we'll open up our project. This is just going to be our simple tank fill system that we talked about before. So our PLC. Oh, I'm a step ahead of myself there. And so I know I mentioned a couple times, but you can absolutely have students download this Open PLC program, have them play with it to write a little PLC apps. You can run the PLC server, which is what's running here in the background, just a simple web server. And it's part of this Open PLC package, and that allows you to emulate a PLC on this side. So this isn't a super fancy VM or anything else. It's a really basic Windows Ubuntu system with this Open PLC system set up on it. You wouldn't even have to use a desktop version. We only did that for the purposes of making it a little easier for people to navigate. You could absolutely make this a really tiny VM that's on a network for you to connect out to. Pretty sure it's the advanced one here. There we go. So we got that up and running. We're good on that side. Go back to our SCADA box and make sure that our HMI is connecting up. Got the green light. And as we can see here, everything seems to be working. We must be on the downhill slope, and we are. Great. So I'm going to bounce a little bit ahead here. So one thing we are going to change in here just to make this more of a realistic environment on the FUXA side is we're going to go back to our editor and to our settings, and we're going to look at our layout up here at the top. And on the show login, we're going to go ahead and enable that because normally you would have a login into your SCADA system, right? In all the labs so far, we've just been trying to teach you what a SCADA system is and all that kind of stuff. But normally you would have a login into that system. So we're going to set up that environment, and we'll go ahead and hit OK down here to change those settings. And then we'll go back up here to the editor, and we'll go out to our settings. And on the authentication with the token, we're going to change that to 15. Go ahead and hit OK. And we can go ahead and close our SCADA system up here. All right. And so all that did was get the environment ready for us to get started. So we'll go ahead and open up our tower here. And we're going to set up our connection back to FUXA. So we'll connect there. And you'll notice this time around, we got a normal sign-in screen, which we would expect on a SCADA type environment, right? So we're going to go ahead and launch a terminal. And we should be able to see this go. We're going to go ahead and just open up another tab. We're going to go ahead and set up a PHP web server. This is just purely because normally a SCADA system would have like a web server running for some of their stuff. What we're really focused on here is setting up an FTP because that's normally what you would have for the PLC controllers in order to update their firmware. Remember when we looked through the Wireshark files and things like that, they were using FTP in order to upload and do those things. So we're going to run a simple PHP script in the back here that does on port 8000. That we are launching a nice little web server. And now our lab environment's all set up and configured. We can go ahead and start the lab as if we're in the eyes of a hacker now. So again, that was just setting up the environment, trying to get everybody ready to go. So we're going to start off on our Kali box because that's where we would go. And we're trying to get that deep pivot all the way into that industrial network. Set up our box here real quick. All right. Make sure we got it configured correctly. And we do with 2.5. So again, where we left off that last time was we had set up this really cool SSH tunnel for us to get all the way into the firewall and such. But we had to set up a fancy port. And then we had to kind of know the remote ports and all that kind of stuff. So now we're going to do that with a dynamic SSH tunnel, which means it's going to allow more than one ports to automatically reflect through that SSH tunnel. So we're going to set up SSH-D 9000-FN, and we're still going to set up that same thing that we had before. So operator 1 at 172.16.2.4. And this is going to come up. We'll do a yes, and this gets us in for that SSH tunnel all the way across. So again, we can do a netstat. And we'll see that we now called it port 9000 for this little remote tunnel. And that allows us to reflect into whatever we want from that far side. And then we're going to use proxy chains so that we can do more than one port coming through that 9000. So it allows us to mux. Yeah, exactly. Great catch. So we're going to be able to mux a bunch of traffic. Now, for those of you that use NetLab, you'll know that this is how NetLab works in a way. So in the old days, and it doesn't quite work like this now, but it used to, what it allowed you to do was get your VNC consoles to all the virtual machines that are running back on the backside of NetLab to proxy themselves through the NetLab appliance. Exactly what I see here. So this little console to this virtual machine, each one of these I click on, is setting up a individual VNC connection to the ESXi host. In this case, this is still running VMware. It sets up a VNC connection to that ESXi host to get to that virtual machine. NetLab is essentially muxing all of that traffic over this port 80 so that we don't have to have a bunch of VNC connections open for everybody to connect into. All right. So we're going to use proxy chains. And that's a simple configuration file. And so we'll scroll down here and you guys can read about doing SOCKS tunneling and proxies. Again, it's really cool to use as an administrator. It allows you to do a bunch of different things over a simple SSH tunnel. So what we want to do here is change this slightly to use 9000 because that's the port we set it up. We got that there. We can go ahead and save that. And now we can use proxy chains to then chain with our RDP client, and that allows us to remote desktop all the way into the SCADA system like we had set up before. But this dynamic tunnel allows us to do quite a bit over that same tunnel. So we're going to use proxy chains. And then our simple RDP tool. And one thing to know, obviously with your students, you're not going to pack 14 labs into 2 days. So you get a bit of a chance to kind of describe what's going on or maybe play with these tools a little bit more ahead of time, where this is almost like a boot camp style of trying to get you to get through these labs, but give you highlights of what this lab set can offer. All right, so the only addition you'll see here is that I'm going to go ahead and set the resolution for my RDP connection. We're going to just simply set it up as an 800 by 600 type connection. So this all works. Let's set up our Y. And so we're back where we left off on the last lab, in that we now have access down to that industrial control network on the engineer's workstation, right? So let's go ahead and launch Chrome here. And we'll notice right away it takes them over to that FUXA system, which makes sense, right? This is the engineer's workstation. Their whole goal is to be watching that SCADA system and watching the HMI to monitor what's going on in that industrial control network. So it's entirely what would be happening off that engineer's workstation. Again, normally in a real environment, this SCADA system here is actually more of a server type appliance. And this PLC is obviously a physical box, not a virtual machine. And that's the reason you see these set up here. So this is going to end up being some service running on a server or a physical appliance. And then your PLC is actually a physical logic controller. All right. So on this login here, we're going to go ahead and see if operator 1 has admin privileges in here, right? We know that they had admin privileges on the PC and such. We're going to see if they have access over to this system. And it makes sense that it would be the same username and password, because who doesn't use the same username and password for multiple systems, right? And we also know that in this case, they're using Active Directory. And so it's going to pull those same credentials from the Active Directory or the LDAP server in order to get them in there and work. So that worked out just fine. We're able to see the HMI. And so now as a hacker, we could go in here and look at the system. And you'll notice that I can't get to the editor, right? And this is pretty common. So nothing happens when you go through there. You can try to click on some of these other icons. And if we expand this a little bit, you could see a little bit more, you know, our standard setup that we were seeing before, just like that. We really can't get anywhere. And so you have access to see the system, and you can see it's kind of controlling some kind of tank with a liquid. When we logged into this, we saw that we were going to 192.168.2.10. And so we need to gain access to this server because it's the one controlling the PLC systems, right? So SCADA systems will often use FTP in order to upload configuration files and firmware to PLC devices. And so those PLC controllers, again, were designed to be something other than networking devices. Networking came much later. Again, they were serial network communications before. Then they added in the Ethernet side of things using Modbus TCP, right? So often they require more CPU services to run these extra services, and this includes taking things for granted like us, which is encryption and authentication. They care about safety features, not confidentiality. And so PLC controllers focus on their programming. They must be reliable. And there's a strong possibility that FTP servers on this network don't use authentication, as a lot of PLC controllers don't support it. They just can't handle it. That Click PC is a good example as you play through there. If you go and look at some old Allen Bradley equipment, Siemens equipment that's out there, they don't even have the option to set up authentication on them. The ones that do are clear text authentication for that as well. So it's really, really common in that portion of it. So with a little bit of background there of what we would typically see in networks, we're going to go ahead and just open up our command prompt. And we're going to see if there's an FTP server on this SCADA system. Again, it's pretty common because that's how you get configuration files from the device. So we're going to run an FTP 192.168.2.10. And sure enough, it's asking us for a user, and I hit enter, and login failed, right? We need to have something. And this FTP server is anonymous only. Makes sense because these PLC controllers, again, can't do any kind of credentialing. They're meant to just point to a place, suck down the file, and use it. We've seen this in the Cisco realm on Cisco routers and switches using TFTP, even worse back then, as we had no way to do that. But it's a lot like those TFTP servers where we're just trying to suck down iOS files or config files. So I'm going to go ahead and restart this connection, and I'm going to do this as anonymous. And you can see my login was successful, and I have an FTP here. So let's do a dir, and we can see that there is a pub folder out there that we would have access to, but we're in that root directory. So let's go into that pub folder. And let's go ahead and make an images folder. So mkdir images. That looks like that worked just fine. And we're going to go into that images folder. And we're going to try to play a little bit. So we still got to figure out a way to get down to this SCADA system and some way for that SCADA system to get back to us. And we're going to know that this has this PHP web server running on port 8000, right? So what we want to do is it has this FTP server already running too. We're going to try to upload something into that web directory, that web server that's running, in order to see if we can't create a reverse shell all the way back, all right? Again, we're just we're using what they give us, and we're creating this cool new pivot in order to get out. So again, for a visual representation, you have this SCADA system. It typically has an FTP server built in so that you can manage the configuration files of your PLC systems. It also has a web server up and running on port 8000 that's just hosting a local site. Again, common, it usually hosts documentation for the SCADA system. And then you have the actual SCADA interface, which happens to be running on 1881 in this case. So now that we have access to this FTP system, what we're going to do is upload a shell into there. All right. So we're going to go to our terminal here. And this is on our Kali Linux box. And we're going to go edit one of these PHP reverse shells because this is a PHP web server. There are some vulnerabilities that we can do there. So we have sudo nano. And out in our share stuff, there's one baked in for us. Web shells, PHP, whoops, and our PHP shell. Great. And so this is one that's already on the Kali Linux box. We just need to figure out a way to edit it, and it is a reverse shell implementation within PHP. But we got to set up some information there, so we're going to hit that down arrow. There we go. And we're going to need to tweak the IP address. So in this case, we wanted to reverse shell back to our Kali Linux box. And note, this is going to reverse shell all the way back out through the corporate network. So 172.16.2.5. And we're going to run this on port 4444. Okay. We'll go ahead and hit Control X and Y and save this little shell. And so now we need to upload this to that FTP server. So we're going to make a copy of this from the Kali Linux machine. There we go. We're going to go ahead and just put this into our downloads folder so it's easier for us to copy up. Okay. And then on a Kali Linux box, for those of you that haven't played with this, this is a really cool Python command that I love. And it is Python 3-m http.server. All right. And I use this all the time. What this does is just turn Python into a really basic HTTP server in whatever directory you run it on. So I've done this on my computer, like here on campus, we have public IPs. If I just run this simple command, it immediately creates a web server in whatever directory I'm in and just has a directory tree running there. It's a great little hacking tool to make it easy for us to accept files or get files. So I'm here in my home folder, and I'm just going to run this command. It gives me a little HTTP server running on port 8000. I can now go back to my RDP session, back over here on this engineer's workstation. And if I minimize this connection here, and I create another little tab over here, I could go out to my little web server that I just did on my Kali Linux box. Again, this is usually out on the internet or whatever else. 172.16.2.5 on port 8000. And if I go into the downloads folder, I have that PHP reverse shell in there. So php-reverse shell.php, right? And I never even downloaded anything. All I did was just go to this directory file. It pulled it down here, but I don't actually have to do a whole lot with that thing. It just sucked it down there on that side. And because of that, if I go back to my terminal over here, sorry, we're not quite there yet. I got a step ahead of myself. We got that file down from our Kali Linux box. Now we need to upload that into our the SCADA system. So we're going to put downloads PHP reverse shell. And my connection timed out because I waited too long. So I need to reconnect, and there's a couple different ways to do that, but for the sake of time, just going to do a quit and reconnect to that FTP with anonymous. Great. And so now I can do that put command. So put downloads PHP reverse shell. And so we pulled that in, and it looks like didn't create the file. What did I do wrong here? Oh, I logged out, so I got to get back in there. So if we do our dir, remember we have our pub folder, so I need to get into that pub folder. And we have our images folder. Great, and nothing inside there. This is where we would do our put command. And that worked just fine. So we uploaded this nice little PHP file out there. And so we want to go ahead and set up on our Kali Linux box up here in the terminal. We need to have that reverse shell connect back to us in some way. So I've got this little connection here. And we're going to use a very simple netcat like the one that we had used prior. So on netcat -lv, or I'm sorry, NVLP. Remember what that does is N does no domain name lookups, V is verbose, L is a listening port, and we're doing this on port 4444. And you'll remember that's what we set up for our little proxy chains as we were going through there too. Okay. As we go back to our RDP session, and we go back to our Chrome over here, now all we have to do is go to that SCADA system that's hosting that little reverse shell file that we created. And so we go here, 192.168.2.10 on the 8000 port. And on images, we are going to that PHP file. So I'll pause here just to kind of give some context as to what we've done. We have Kali Linux running out here on the corporate side. We have our RDP session to this engineer's workstation. We created a backdoor file on the Kali Linux box, in which case we hosted for this engineer's workstation to pull down. We just created a little web server on the Kali Linux to suck it down here, just make it easy. Once we were on that engineer's workstation, we were able to get access to the FTP server on the SCADA system. We put that reverse shell file into that SCADA system. The SCADA system is running a web server in the folder that we created in the FTP side. And so now what we're going to do is from the engineer workstation, we're going to access the web server on the SCADA system, pointing to that PHP script that we created in there. All right. Hopefully that all makes sense. And so now when I hit enter, you'll see that nothing happens over here. But on the back side, what happened was it sent a reverse shell connection all the way from that SCADA system clear back up to our Kali Linux side. Just like we did with all those other tools all along, we set up that backdoor. And so now if we do a who am I here, we can see we are on the SCADA system with the SCADA user. If we do a host name, we can see we're on that SCADA system. And at this point, we could go ahead and actually break clear into the PLC system using all the stuff that we had learned in prior labs, right? Like in lab 10, we could perform our man-in-the-middle attacks now. We could do our denial of service attacks on the system. We could do anything we wanted now that we have access to that SCADA side. So in the end, we were able to reflect from here through the firewall to this engineer's workstation. Then from the engineer's workstation, we created this little tunnel back to SCADA. And now this SCADA is going all the way back through all this firewall stuff back to the Kali Linux side directly. We now have this locked in shell clear down to their SCADA. And if we wanted to, we could start doing some damage from there, right? So we would have to bring up some tools over there to do that, because we don't have tools like Mimikatz and all that on the SCADA side. So we would do some simple file transfers in order to get them to pull those files down. We could do that through back here on the Kali Linux side, right? We have this web server up and running. And so all we have to do is dump files into our downloads folder, and we would gain access to that over here on the SCADA side. So it's pretty cool. On the back side, again, we can pretty much take over and do whatever we want now. All right. How many people did I lose? Yep, passed out with your hand on the reboot button. I get it. I get it. It got super technical really fast there. But the idea is this is how you would go through and hack an OT system being an IT person. So now, at what point could we have fixed all of this? Does anybody know? And by fixed, I mean, as a administrator of this entire corporate network, how could we have fixed things along the way? Yeah, we could deny all ports. That could be a little tricky. We could at least button up our firewall, right? I mean, for one reason, we should never allow traffic to go from SCADA all the way back up to the corporate side up here, right? So one, we can't go from here all the way down, but evidently there's traffic that allows this SCADA to go all the way back up to the corporate side. That's probably a no-no. We could deny that right there in the firewall. They did good. They blocked traffic coming this way, but they didn't do outbound traffic and deny any restrictions in that regard. We would also want to make sure that we clean up our remote desktop stuff. That if we're going to use it for troubleshooting, that's great, but we obviously need to clean that kind of stuff up there as well. We want to probably try to get our operators to use non-standard passwords if they can. Again, in some cases, there's no chance of that happening. We should not let this operator use the same credentials on their corporate workstation as they would on their engineer's workstation. That pretty much allowed us to get way deep into the system. We also wouldn't want to leave them with admin privileges over here on the corporate workstation. So lots of areas that we can fix that. And ultimately, when I teach this in class, this is where I actually have them write up for the final. So it's cool to do all these labs, right? But now I want you to give me a write-up as a report, as an audit, what the administrator should do. And I want step-by-step instructions on what they should be looking at to fix. And so that's one way that you can get an answer back out of a student that actually went through these labs that AI just can't give them, right? AI doesn't know what happened in this lab set. So they would at least have to feed some solid information into the prompt in order to get some answers back. Not to say that they can't do it, they could. But you definitely want to try to challenge the student to write a report. And ultimately, in the real world, that's what matters. It's not, can they hack all the way in here? Great, you took over my network. How do I fix it? And if they can't explain how to fix it, it's going to be much tougher for them to have a job. All right, we have hit the 3 o'clock mark. And so, as a matter of fact, we're at 3:15. So let's take a little bit of a break. And then when we come back, I want to get you guys access to the ethical hacking labs so that you guys can go out and practice some of those skills that we talked about, learn more of these tools and what they really are and how they work. See if they're useful in the classroom. If you decide to use them, you can use the NDG Online if you wanted to. You could host them locally if you wanted to. But see if they would be useful in some of your cybersecurity classes. But we'll go ahead and take about a 15-minute break. We'll come back at, let's just do a straight up 3:30. And that way you guys get enough time to refocus here. And I apologize for the deep context of all these labs. It gets pretty deep pretty fast as you try to break your way into an OT side. All right, let's throw up the clock. I'll see you back here shortly. All right. Hopefully we're back now. I forgot to pause that recording and such, but let's see. I wanted to get you guys access to the ethical hacking stuff. So I am going to turn off the recording real quick in the video just so it's there.